record this presentation just so I have it for my own records. But if you don't want to be on the recording, you can just take your video off. If you are on video, I appreciate it just so I have somebody's face to look at, but you don't have to be. I'm just going to kind of scroll through here and see if anybody is on video. Nope, just me, and that's perfectly fine. So my goal today is really to talk about pond turtle nesting ecology, but it's going to include lots of other things too. So just because we're going to talk about pond turtle nesting ecology doesn't mean we're going to avoid a lot of other natural history. So we are going to talk about all that natural history. I'll start off with that sort of basic stuff to give you guys a context, and then we'll move forward from there and eventually get to pond turtle nesting. In the field, we'll talk a lot more about this, obviously, because it'll help when you see things in the field. The field site we're going to go to, we'll talk about a little later before we end, meaning some logistical stuff, that sort of thing. We'll probably take a break at the hour, so about 9 o'clock, we'll take a break for about 10 minutes and then come back. If we make it to 10 o'clock, we'll take another break. I'm pretty sure we won't make it till 11. So if you have a question, I'm gonna, I've broken this up into sections. So I'll talk a little bit about, for example, the status, and then there'll be kind of a slide to prompt me to pause and ask if anybody has any questions, and feel free to just jump in with your questions at that point. Because I can't see anybody's hand raised except for the first few people, just start saying something. I'll try to be quiet for a moment, just say I have a question, and then we'll just jump in and everybody can hear the question together. Any questions about all of that? No. Good. Okay, so moving right along here, we're going to start with something very basic, the status, the range, and the ID. It seems really basic, but it's actually going to be quite complicated. But we're going to just kind of give you the general overview. So the status originally was just a common species. You could trap turtles, eat them if that's what you chose, have them as pets. But in 1994, it got elevated to species of concern. At that time, it was just the western pond turtle, and you can see in that upper left illustration, there's a little pond turtle on the cover. That was because when these authors wrote this book, the pond turtle was in pretty good decline, and they wanted to highlight the species. So there it is on the cover. As we kind of progress a little further along, we're around 2015 or so, this new version of the species of concern came out, and the pond turtle's still in that. So between 94 and about 2015, the pond turtle didn't do any better. In fact, it did a little bit worse, and so it's still a species of concern in California. So as far as the state's concerned, it's a species of concern. But getting sort of the bigger picture, and now we're going to split the species up because that's the way we see it now. We don't have western pond turtle anymore. We have northern, actually is converted again to northwestern pond turtle, and southwestern pond turtle. And then we have an undescribed species that we won't talk very much about, but that occurs in Baja California and up into San Diego County a bit. So the northwestern pond turtle, and I'll show you a range map in a moment, is going to be a California species of concern. It's also, if you go all the way up into Oregon, it's a critical species of concern in Oregon. That's essentially like kind of endangered species. In Washington State, it is endangered. There's only a few populations, I think 6 or 7, and all are in really terrible decline. And then our species, at the time it was western pond turtle, now it's northwestern or southwestern, was petitioned for listing in 2013 by a lawsuit from Center for Biological Diversity, which is typically how things get listed these days, and has been under review since then, so about 10 years, and we'll talk a little bit about that in a second here. Now we have the southwestern pond turtle, so we have 2 species in California, and it is also a species of concern because when it originally was described as a species of concern as western pond turtle, it included 2 subspecies, the northwestern and the southwestern. Now that they're species, they're both species of concern. Again, the same thing happened with the federal listing. So once it was split off, they both became petitioned for listing in 2013 and are and have been under review. So in 2022, the southwestern pond turtle, not the northwestern, but the southwestern, which is going to occur from San Francisco along the coast south to Baja, was elevated as a priority listing. So they were going to list it in 2023 in July, August or September 2023, but something happened politically and they're instead going to list the spadefoot, Western spadefoot. So southwestern pond turtle is going to probably be on the next round of listings, whenever that is. These things are also very political, so we'll have to kind of wait and see. And then I put Baja California pond turtle in there. That's not the official common name. It doesn't have an official common name. That's just a kind of the common name we're trying to use right now. Doesn't have an official species name. That's the one I think that's been promoted, Bajaensis. Just in case you are in San Diego County and in one of the two ponds that has this species, it still is just a species of concern in California. Again, petition for listing federally, probably will be listed as endangered by the federal government. And then in Mexico, where it occurs primarily in Baja California, there's no status for it. It's just a common turtle down there. So moving on to, I just often when I'm doing lots of slides with words on it, I put a photo back up to show what we're really talking about, kind of remind you guys that I do have the turtle in mind, just not all these words. So here is a couple of maps that talk about the range. So on the left side, this was the old map back when it was Western pond turtle, and it's all in red, so it was one big species group. And then I have this green hashed area where they just didn't know what was happening. Seemed like we had both subspecies in that area in this San Joaquin Valley in the Sierra foothills south of Calaveras County. And it was kind of a big unknown area, partly because there was a lot of turtle farming in the early 1900s. But if you look at the map, the number 1 represents the northwestern pond turtle, and the number 2 area represents the southwestern pond turtle. But it was only really dictated by a single scale that I'll show you in a second. And then we have these few blobs out there near Nevada and one in the desert. These are populations that were probably translocated and have since mostly gone away. So if we shift to the right side of the screen, this is a more updated map. So everything in green is the northwestern pond turtle. Everything in yellow is the southwestern pond turtle. Down there, that little tiny orange blob is going to be the Baja pond turtle. We're just going to ignore that from this point forward. There's that little blob out there, yellow blob in the desert. That's still a population that exists in the Mojave for the southwestern pond turtle. And then, yes, I see that pink blob in the Bay Area where lots of us work. And the point here is to say we don't know what we have there. And I'll talk about that. I'll update that with another map here. But the idea is that there was a tremendous amount of pond turtle nesting, or sorry, farming in the early 1900s that primarily occurred in Contra Costa County. So they were bringing different subspecies to that area. And at some point, the market kind of collapsed and the turtles got released. And so we now have a mix of both what used to be subspecies is now species, and we really don't know what's going on there. And by really don't know, I mean to say we have a mix of both. Excuse me. So here's that kind of updated close map of that area. And the green is northwestern pond turtle, the yellow is southwestern pond turtle, and those will probably be the ranges of the species. But you can see there are populations that I've marked out that I'm aware of that have the other species within, for example, the yellow dots are southwestern pond turtle within the northwestern pond turtle range. And the same is true in Contra Costa County and Alameda County, where you have northwestern pond turtle in the southwestern pond turtle range. So this is going to cause quite a bit of grief, but what I've heard very, very recently from the service is when they do list it, and they will list probably the southwestern pond turtle as threatened, they're just going to draw a line on a map and say everything south of this line is southwestern, whether it looks like it or not, and everything north and east is going to be northwestern pond turtle. So there will not be genetic differentiation or morphological differentiation. There's just going to be a line on a map, and it'll make it easier for everybody. But if we were going to differentiate morphologically, and we'll see this when we go into the field, because at the site I'm taking you to, we have northwestern and southwestern pond turtle. So what we used to identify these is just from a paper from 1944, and we're looking at a single scale on the turtle. It's called the inguinal scute or the inguinal scale, and it's near the back leg. So the lower left photo, you can see the head is pointed to the right. My finger is touching the back leg, and the arrow is touching a small triangular scale there. So it doesn't look very obvious, but that little discolored scale that's kind of darker green is called the inguinal scute and is about the size of my pinky fingernail. So if you see a scale that is in that position that's triangular, about the size of your pinky fingernail, it's probably going to be northwestern pond turtle. Now, if we move up to the upper right, that's a southwestern pond turtle, and we know that because that same scute is not triangular, is not the size of your pinky fingernail, but it's more like the size of a grain of rice, or it can even be absent, could be gone, not even there. And if we're lucky, we'll trap a few turtles. We'll look at those individual turtles side by side, and you guys can take a photo and see the difference. That historically has been the way we know southwestern from northwestern. Now that they're species and they have to be listed, we're really going to just go based on a geographic line on a map. But just be aware that in some sites you're going to have both species. But in the bigger picture, nobody cares, because if you're below that line that the service is going to draw, you're going to have to call it southwestern pond turtle. So it's more of a detail than anything else, but it's one of those things that's good to know, because one will probably be threatened and one will probably be remain as a species of concern.
Hey Jeff.
Yeah.
Um, so I saw a pond turtle recently that had the inguinal scute larger on one side than the other side.
Yeah.
Have you ever seen that? I thought that was kind of weird that one side, like, are they commonly smaller on both sides or larger on both sides? Like, have you seen that?
Yeah, I have. What county were you in?
I was in Alameda.
Yeah. Not
Yeah.
surprising. So that's probably a hybrid. So they don't know the difference at all. They're not looking at that scute and saying, "Oh, you're not my species." They're just saying, "You look like a turtle that I can mate with, so I'm going to give it a shot." And from that, we'll get some that have intermediate shapes, or one small and one large, or something that has maybe zero on one side, so no inguinal scute, and something large on the other. And that's sort of the baffling part that we're left with, because they've been intermixed in this area, Alameda and Contra Costa County mostly. Also, in some areas where people have just released pet turtles, we're going to see that there too. We see it occasionally in the Sierras. So yeah, this is just a hybrid. So, but if you're in Alameda County, they're going to draw the line north of that. It'll be probably going right through the Delta, right through the San Francisco Bay Estuary. And so everything in Contra Costa, Alameda, San Francisco County south would be southwestern, as long as you're in the Intercoast Range or South Coast Range. There'll be a map. I actually have one above my computer here that I can look at that will show the range, and it'll be hashed out as, whether you like it or not, or I like it or not, or anybody else likes it or not. It'll all be considered southwestern pond turtle just because you're in that range. But yeah, I have seen that. That's interesting.
Okay, thanks.
Okay, so let's see what I. So just a little bit more about ID. Occasionally I'll get photos emailed to me or texted to me, and there'll be just a photo of a turtle, usually the back, so the carapace, the one on the left here. And somebody says, "What kind of turtle is this?" And I have to try to figure it out based on the photo that they sent. If you're going to send me a photo, I'd prefer the top and the bottom. So the carapace is the top, bottom is the plastron. It's super helpful to see both, and also photos of the head, because we have 17 different species of turtle in California, with 15 of them being non-native, and some of them are really tough to know one from another. But generally speaking, here's the carapace of the. We're gonna From this point forward, I'm gonna just call them pond turtle, which will cover northwestern and southwestern. But all the behaviors I talk about will apply to both. So pond turtle on the left, carapace, you can see, has, to me, a very distinctive patterning. The plastron on the right, same thing. It's very distinctive to me. But when you hold up something like a peninsula cooter, which comes from the East Coast, you can't always tell the difference very easily, even in your hand. So we use tiny little details. One of them that's pretty common to use is the margin. So the shape of the turtle itself is relatively smooth on its edge as you go around it. Where if you pick up something like a red-eared slider, the bottom portion of the carapace, so the portion where the tail and the back legs are, is going to be heavily serrated. So we use that, which is why I say if you're going to send me photos, send me the top and the bottom, not just the bottom or the top. On the plastron side, the coloring and marking is highly variable. It can be all black, dark, patchy, whatever. If you look closely at the photo I'm showing you, you can see what looks like little lines that make up each of these little scales. Those, we'll see this in the field, those are growth rings. So on this turtle, I haven't looked at it until right now. I'm going to say it's a little like a tree. So if you look at it and count those rings, you can age the turtle. So I'm going to count that just looking at it. 1, 2, 3, 4. So this looks like maybe a 5-year-old turtle. So I'm counting a couple of those scales. Sometimes they'll be polished smooth and you can't tell because they live on rocks. They polish that bottom smooth. But there are other places you can look and check. But we'll do this in the field so you guys can get an idea of this. So turtles generally are mature at about age 5. So this would be a mature pond turtle. But we don't necessarily want to go by size because in different areas they grow at different rates. But generally speaking, I'm just going to familiarize you with the idea that the carapace is the top, plastron is the bottom. But if you say top and bottom, that makes sense to me too. So we're going to go through male versus female. So this is a side-by-side comparison, and I'll go through each of the characteristics, and I'm going to tell you in advance that you should use more than one characteristic. Even the ones that seem really foolproof are not foolproof, and we'll talk about that in the field too. So I'll go through each one of them, and as many as you can use, you should use, because we've had turtles in the field, and I'll say this again, in the field, where we looked at the site for 12 years and we're trapping turtles for all that time, and say number 76 is male in 2015, and then somebody catches it and they mark female in 2018, and in 2020 they mark male again, and in 2022 they mark female, and it goes back and forth because some of them are a little tricky. It's hard to know. So you might come across those occasionally. It's not very common, but probably in the 2 to 3% range, where it's really just pretty tough. And then anything small, meaning young, you can't tell the sex anyway, so you should be writing unknown for that. But for the ones you can tell, I'm going to stop myself and just say, we're looking at the plastron here, and if you look at the turtles, you see their plastron is polished smooth, so no age rings, they're called anguli, no rings, so we can't tell the age. And if you look past the turtle to the habitat, you see it's rocky. So that's an example of where, if I show you this one probably basks on logs. You see the grass in the background, might sit on mud. These ones sit on rocks. So they've polished their plastron pretty smoothly. So there's that problem you have if you're trying to age turtles. These are all just considered 10 plus. We don't really know. Okay, so going down the line of the sexual characteristics. So on the left is a female, and on the right is a male. And if you guess that, great. But I'm going to show you why I think this. So the cloaca, which is the reproductive orifice and also where waste products come out, is a small hole in the tail there on the bottom. And the distance between the edge of the carapace, so the top of the shell, and the cloaca is very small, or the cloaca is within it, so closer to the guts of the animal, closer to the head than it is the edge of the cloaca. So it's either on the edge or it's within it, so inside of the edge. On a male, it's well past the edge of the carapace. So you can see that on the right side where I make 2 green lines that are saying, okay, the upper green line is the edge of the carapace, the lower green line is where the cloaca starts. So if the cloaca is well beyond the carapace, that means that it's likely a male. Now there's a little funny opening here in the bottom of the plastron where the tail comes out, and the angle is quite different on male versus female. So the male's is very open. The angle is very open, almost flattened, where the female's is pretty closed down, almost 90 degrees. The normal shape is probably more female-like. Like when you get an immature, that angle is going to be pretty tight. But when you get a male, the angle is open, and that's primarily because it needs to move its tail around in order to mate. So it needs a more open angle there. So that red angle is open on male, more closed on female. And I know I'm saying like these sort of vague statements like more than this, less than this, and it's a relative thing. So it always helps to have one of each of them in your hands. But it also just takes experience. But some of these characteristics aren't too hard. So one that most people use is the plastron. Is it flattened, like on the female? So not concave, it's flat. And if you push your hand over it, you would feel it's just very flat. On the male, there's a bit of a dip. So if you pulled your hand over the carapace, I'm sorry, the plastron, it would just fall into a little dip there, and you would feel like, okay, there's a little concavity here. And that's so that when the male mounts the female, he can get closer to her, and that little impression is sort of an indentation for her carapace, the top of her shell, so he can get closer. And then he needs his longer tail, which he has, to reach under her in order to mate. And if we get male and female together in the field, I'll show you how all that works. And then again, I just said it, the male's tail is much longer than the female. And again, it's one of those vague things. It's a relative thing. So you can see the two white lines. The tail starts at the upper line, ends at the lower line. The male's tail is so long it's outside of the photo. We can even see this if they're basking on a log. If they stick their tail out, you get a pretty good impression of the tail length pretty quickly after you see a bunch of these. And then the female's face is often mottled. So the problem is that all the immatures also have a mottled face. So unless you know the age of your turtles or relative age of your turtles, you don't want to use the modeling to ID it, but females tend to have a mottled face. Males tend to not have a mottled face, and as they get really old, the males will have just kind of a light or beige face or cream-colored face. And I show that more here. So female, even though I wrote it in white in the light blue sky, you can't really tell. Female is on the left, male's on the right. So female has a very mottled face here. Male has a very beige, tan, pinkish, light-colored face with very little modeling at all. And so you can see where I'm pointing to in terms of modeling. The modeling is very distinct on the female, not so distinct on the male. But if it's an immature turtle, so maybe a 4-year-old or a 5-year-old, you can get a lot of modeling even though it's a male. So that's why I say use tail length, cloaca position, concavity in the plastron, all these different things, you want to use them all. And then finally, here's another male and female together. We want to use the carapace shape. So on a female, it's very rounded. It's kind of high. This again is, I'm saying, vary. I'm not giving you a number. It's a relative thing, but it looks more helmet shaped. And on a male, it looks much more flattened. We can see this from a distance pretty commonly if you have good binoculars or a scope. If they're basking, you can see that there might be 2 or 3 males and their carapace is flattened, and there's a couple of females that have short tails and big sort of rounded carapace. You can use that to help you identify if you're trying to do male versus female. But again, use all those characters together if you can. That would be the best thing you could do. Anything about range, ID, status? Okay, great. It's straightforward, and we're going to repeat it all in the field. I know I'm going to give you a ton of information. You're going to maybe remember 5% of it, and that's expected.
I have a quick question.
Yeah.
So just I want to just have you reiterate for purposes of basically agency and regulation, the North and West, despite the fact that they kind of hybridize or whatever in that zone, for purposes of regulation, it's just going to be a cutoff. This is Northwestern, this is Southwestern. Is that correct?
Exactly. They're going to give you a map with
Okay.
a line on it.
Okay.
But until it's listing, we don't really know if you're in Alameda or Contra Costa County what you have, but we're going to call them Southwestern, even if they're Northwestern. But for example, I have a project site and we're going to visit it on Sunday, Monday in Martinez where we have both species. So if I find something and I want to publish it, I either have to decide what it is, I look at it and check the inguinal scute and write that into the document, or I make the assumption that they're all Southwestern, and sometimes the journal will do it. Even though I'm looking at Northwestern pond turtles or it's nesting. Like I had a turtle that was nesting and it only had 3 legs, and the rear leg was missing, but it was able to make a nest anyway. And so I wrote that up, and it was a Northwestern pond turtle, but the editor said, well, you're in the range of Southwestern, so we're changing the name. And that's not really biologically sound for somebody to just describe it that way when they haven't even seen my turtles. But it's because there's this general idea that you can't have two similar species overlapping in range. Otherwise, they wouldn't be species. They would be a subspecies that just has overlapping range. So species generally are separated by some geographic barrier. In this case, we don't have it mostly because people have created a problem. But yeah, you're right. It's going to be a line on a map, and that'll make it a lot easier.
Interesting. Okay, thank you.
I have to say, I think it's a lot easier too. I don't necessarily like it because I don't think it's very biological. And then people have looked at the genetics and have found just some puzzling issues with the inguinal scute itself too. So I think that it's such a messy situation that most of us, and I'll just use myself as an example, I've studied turtles for a very, very long time. I can still mess them up easily because they might look like Northwestern, but if you check the genes, it'll say Southwestern. So often it is really just better to use the line.
I have a question as well.
Yeah.
You mentioned that there's 15 non-native species in the state as well. Do you have any photos of like what the difference between those might look like, or what we should look for to know for sure that it's a Western pond turtle?
Yeah, I appreciate that, Katie. So here's the thing. We're working on a paper for this right now. But the problem is there's variability in all the non-natives. So to show you the variability in all the non-natives would really be pretty darn tough. The other problem is that we don't always see turtles like sitting in your hand. We often will see like a head sticking out of water, and you're going to have to define what species that is based on a head. And I can tell you that there are probably 5 species of non-natives that I can't differentiate just based on a head. They're just, I can't tell. I would have to trap. So I often say to people, get an SCP, a scientific collecting permit that allows you to trap turtles, because in order to know, you're going to have to actually have the turtle in your hand. And some of them, even in your hand, there's a couple of cooters that I have to look like straight down at the face, look at one of the scales on the carapace, flip it over, look at the toenail length. And, if I'm having to do that, I definitely have to have it in hand. People will send me photos and I just say, ooh, I don't know. And they might even be good photos, but the general point I'm trying to make is this is actually a great excuse to get a pond turtle trapping permit. Because if you can't identify them, and I would say the people that can identify every species in California probably equals 0. And that means in the hand, yes, that's a different thing. But in the water, 0. I can't do it. And I'm writing a paper on the non-natives, and I've studied Western pond turtle, or these pond turtles, for quite some time. They're going to just be some species you can't tell. Like I get on an iNaturalist quite a bit, and people have photos and they make a claim of what species it is. And I know it isn't pond turtle, but I don't know what it is. So it's not easy, and I think it is a good reason. Maybe the better thing to say is it's a good justification to get pond turtle on your scientific collecting permit and start trapping and get to know some of these turtles. Some of the map turtles are really tough. There are lots of cooters that are very, very tough. There's one a weird slider That's just very odd look. Looks a lot like a pond turtle. So you'll get a few that are not hard. Like red-eared slider is not hard unless it's a melanistic red-eared slider. Then it switches to very hard. And I want to have like 4 photos. Give me a face shot, a plastron, a carapace, feet, legs. Um, I'm not trying to say that it's impossible. I'm just saying it's going to take a lot of work, and you're going to need to be trapping them.
Okay, thank you.
Yeah.
When's that
And
paper coming out? I want to look at that now.
yeah, we're definitely working on it. So there's 4 of us working on it, and it's a lot of work, but we'll probably have it coming out early next year. But if I can email you the list of turtles, so you'll have an idea of what's here in California.
Yeah,
In
that'd
fact,
be great.
I'll send it to everybody. And what I'll send out is a table that has all these different species and what county we know they occur in, because that'll help you a little bit. Red-eared slider occurs in more counties than pond turtle occurs in. So that one's probably the most likely turtle you're going to see. But I'll send that out today. I'll send it to everybody.
Thank you.
Maybe I should just write a note for myself so I don't forget.
Jeff, I also had a question just going back to the hybridization. I don't know if this is the right place for it, or I'm not even really sure what my question is, but when were they recognized as separate species? If you're saying they can hybridize and they have like the sympatry, you know?
Yeah. It's a really good question, and it's really been a point of contention with lots of biologists. So in 2013, Philip Spinks wrote a paper on the genetics of western pond turtle. At the time, it was western pond turtle, and he was trying to show that there are areas where you get the genetics of both species, and they're sort of mixed in a bit, and we don't really know what's going on there. Why would that happen to an animal that should be 2 distinct species? But part of our problem is we look at the genetics in such a refined way, such a tiny scale, that we may be at the wrong scale for differentiating this. Quite honestly, you can make an argument that this is still just one species if they can all hybridize and produce viable young. That used to be our old rule. And our old rule used to say, well, a species is a species if it's genetically isolated from something very similar and closely related. But it's not working with the turtle. The turtle has been moved around a lot because it's been used as a pet and food. And so the fact that it may have originally been separated geographically was a different thing, that they were on a trajectory of being very distinctly different, and then we started mixing them around and pushing them around and moving them around, and it turns out, well, if you mix them, they can hybridize. So realistically, if we use the old definitions, and I'm an old guy so I tend to, it's probably just one species. But in terms of regulatory atmosphere, these are 2 accepted separate species, even though they intermix and hybridize.
That's a tough one and gets into species concepts that make my head spin a little. So
I'm with you. And I'll be saying this in the field too, because I'll show you 2 turtles that look identical, and we'll flip them over, and one will have a tiny inguinal scute and one will have a large inguinal scute. And you think, well, if they were on a log somewhere, you'd never know the difference. And here we are in the field, knowing that these 2 live side by side, are mating together, having viable young that produce little hybrids that have no inguinal scute on one side, a big one on the other. We don't know what to do. We probably messed it up trying to create a species out of them. Subspecies still works for them, but in terms of management, we have to manage these things. So we generally, the idea is to try to manage them clearly. So we've made this choice, and then we've split the turtle up. If you know Philip Spinks, he worked really hard on this, and later work he did confused the whole thing. So you can see that this particular animal is a confusing one, or an interesting one, depending on how you look at it. I'd call it confusing.
You just mentioned subspecies. I'm up in Mendocino County, and on our permits, we use Actinomys marmorata marmorata.
Yeah.
Is that the Northwestern or?
So the northwestern is Actinides marmorata, no more subspecies. We don't have any subspecies of pond turtle anymore. So you're clearly in the marmorata range, and that's a species marmorata. So we would generally drop the subspecies name. So both Fish and Wildlife and Fish and Wildlife, the service and the department have accepted that it's a species. The state held on to subspecies for many, many years, but the federal is going species all the way. And when they list it, it will definitely be 2 species, and you'll have marmorata up there.
Okay, I think we just need to update our template then.
Yeah, and it's good too, because the people who are turtle advocates see you using subspecies and they roll their eyes. So it's good to have that updated. Okay, we'll move on to, I'm sorry, go ahead.
Oh, sorry, one more question. So when we're filling out our scientific collecting permit, we would have actually 2 permits for both species.
I would do exactly that. Yes, both species, you want to be able to trap both species. So you can trap the non-native turtles with a fishing license, but you can't currently trap the western pond turtle, southwestern or northwestern pond turtle without a scientific collecting permit. So do put both species on there. Even if you are in Del Norte County or San Diego, put both species anyway.
Okay, awesome, thanks.
Okay, so we'll talk a little bit about habitats. So it seems relatively easy to think about habitat and turtle. You know, you find a pond. This one is in the Sierra Nevada. You find a pond, you're going to just look at it and say, well, that looks great for turtles. And if it looks like this, it does look great for turtles. So finding turtles in this kind of habitat seems pretty reasonable, not too tough. But if you look at different habitats, you look at something like this is the Russian River. You start to think a little bit more about it. Do turtles occur in something like this that has highly regulated waters, weird kind of flows, aseasonal flows, so people regulate the flow rate? You know, it's got all these rocks, different dams and things. Is this still good for turtles? It turns out this works perfectly fine. Turtles climb super well, so they can climb through this kind of rocky jumble. They'll use fish ladders, or they'll just go up on the bank and walk around this kind of stuff. So barriers like this don't impact the turtle at all. Coastal foothill creeks that are kind of high gradient, that have a lot of riffles and rapids and these sort of bouldery, tumbly waters don't seem very good for turtles, but as it turns out, turtles do fine in this. They will just use the slower portions or the shoreline edges where it's warmer. And they tend to stay out of the big, raging water. And then on big pulse flows, so either a big rain event or it's rafting season and they turn on the faucet every morning at 5:30 and, a huge pulse flow comes down, they get out of the water and they wait for the flow to stabilize and then they get back into the water. So they can regulate their own behavior to adjust for habitat changes like this. Then in California, there are only a few natural lakes, believe it or not. Most of the lakes we have are reservoirs that we've created with a dam. This is Clear Lake. It's a natural lake. Clear Lake has lots of pond turtles in it, but it has lots and lots of non-native fish and non-native turtles as well. So although this is a perfect habitat for turtles, turtles are still in decline in something like these natural lakes because of all the non-natives and all of the development and the people that seem to want to use the shoreline edge where the turtles typically live. But any lake like this is probably going to be reasonable for pond turtles. Then stock ponds. People don't think about stock ponds as being a relatively new thing on the landscape, but stock ponds were only created around 1950s in California, and then through all the way up to about 1980. Now, we still build a few, but very, very uncommonly. So there was a 30-year period where stock ponds were going in every single day. There was new stock ponds being built all over the state. This is mostly for cattle, occasionally for sheep or goats or horses. But these stock ponds now have become habitat not only for pond turtles of both species, and this is in Contra Costa County, and we have both species in these 2 ponds, but red-legged frog and tiger salamander and spadefoot and lots of other things, including fairy shrimp and stuff. So these stock ponds end up being very valuable sites. Some of them have pond turtles, some of them don't have pond turtles. It really depends on how close that stock pond was to existing habitat that was already occupied by turtles. And then I put this in there because I live in Sacramento Valley, agricultural ditches and drainage ponds that seem to be wet, a few months of the year because they're going to irrigate some land, and then are dry for a long time, are still really good habitat for pond turtles. They use this kind of habitat for lots of purposes, but they'll move in and out of it. So just because it's dry for 4 or 5 or 6 months doesn't change anything, and I'll talk a lot more about that later in the talk here today. But these fluctuating waters that are muddy sometimes, full of water other times, and dry still other times, still are very functional habitats for pond turtles. And I should say, up to this point, I've been really talking a lot about aquatic habitat. I'll talk a little bit about upland habitat too, but aquatic habitat is critical for turtles, and I'll talk about this again a little bit later and remind you, because pond turtles not only need water to thermoregulate, so they need to stay out of like the Sacramento, San Joaquin Valley heat during the summer, and they do that by getting into the water and cooling down, but they only eat in the water. And I know that's going to be like, you're going to think, what? But they are unable to swallow food without the aid of water. So if you have a pond turtle in a box in your yard because you found it on a road somewhere, and you're throwing in some pieces of hot dog for it to eat or whatever you chose, it's not able to eat, and it won't eat unless it's in the water. It needs the water in order to swallow. So think about that. So if a pond turtle is experiencing a drought, it's not eating during that entire drought. And again, I'll talk about that later down the line. Speaking of droughts, here's the Mojave River. It's a channelized system in the Mojave Desert, but there are pond turtles here, and I have the little inset photo there. So if you're standing on this levee and you're looking at pond turtles in the river, which is really more of a canal right now, and then you turn around, what you see is the inset photo. So pure Mojave Desert, really inhospitable, not going to be a good site for pond turtles. But because we manage the water in the Mojave River, it does enable pond turtles to persist there. Now the population goes way up and way down depending on the site conditions and how much water we're using and how much water we allow the turtles to use, but they still are there and still using the site.
Hey, Jeff.
Yeah.
Hey, quick question. What did you say right before you said the turtles only eat in the water? You said something before that.
Oh, just more about thermal regulation.
Ah, okay. Got it.
So if they overheat, it will kill them. So they use water to cool themselves down.
Okay, thanks.
I have a quick question.
Yeah.
You said that they can use water even if it's dry for months, but does it matter like which months those are, or if there's other water bodies that are still wet at those times? Like, what are the limitations there?
Yeah, that's a great question. So I'll have a section on that kind of thing. So what turtles do when it dries out, and it's pretty important, and that's why I included, even though we're talking about nesting, I'll include that because I think it's really important. But it's a great question.
Thanks.
So we'll jump back into habitat just to kind of finish this segment up, and we're still only talking about the general natural history of the turtle to give you that kind of context for what I'm going to talk about in terms of nesting. So habitats like this is a created wetland. They constructed this in November of the year I was working there, and by December there were pond turtles in it, and they just came from the creek that's back there behind the wetland. So created wetlands are great habitats. Certainly the aquatic portion of it are great habitats for pond turtles, and they use them very, very quickly once they find them. One thing that has surprised a lot of people is this kind of feature. So this is sewage detention basin. So you flush your toilet, and all that water and everything in your toilet goes to the sewage treatment plant, and then they use these big ponds to kind of evaporate some of the solids out. So they're evaporating the water, they get the solids, and they take the solids off to some other place. These sites are actually the best sites for turtles that I know of. And by that I mean they're super, super nutrient packed. And you can imagine that in terms of just thinking about like fertilizer. So this water is heavily fertilized. And I'll use quote fingers by saying fertilized because it all comes from us. And so these waters are heavily fertilized. So they're very, very productive. They're often very, very warm. And all of that is just turtle soup. And not that you're cooking the turtle, but the turtles are in this mix of, all the stuff we know goes through your toilet, but um, the algae and all the zooplankton and plankton and all the things feeding on the algae, and then as you go up that food web, all that complexity is available for the turtle. So they're eating everything from algae and invertebrates to vertebrates, and sitting in water that's very, very warm and always protected, because these kinds of sites are really excluded from human contact. So these kinds of sites are absolutely perfect. And the largest known pond turtle, which was 1,700 grams, the average is about 600, so triple the average weight, was found in a sewage detention basin. And we'll talk about this a lot in the field, because guess where we're going? We're going to sewage detention basins. They don't stink, they're tertiary treated water, they'll be good. Well, it might stink a little bit, but we'll manage to get through it. So anyway, the point is, sewage detention basins are great for lots of reasons. And one of those reasons is, beyond being just really nutrient rich, is that they're essentially protected from drought conditions. And by that I mean, these aren't going to just dry up in the fall. Nobody's going to go out there and say, oh, I'm tired of just pouring money into pumping water into my pond to keep it wet for fish. I'm gonna just let it dry. Nobody's going to say that in these situations. What they're going to say is, people keep flushing their toilets, we got to keep processing all this waste. So the general point is, even in drought years, you're going to flush your toilet. It doesn't make any difference. You might flush it a little less, that's your choice. But you're still going to flush it, and there's still going to be these basins, and they're going to be drought-resistant habitats for turtles. And if you travel around, especially through the Central Valley, to the different sewage treatment basins, you'll see many pond turtles. Now, you'll see other species too, but these are really good habitats. In fact, they're better than mitigation ponds in most cases, just because of that very, very high nutrient load. Let's see, this is a photo of a site I work on in Baja, California. It's pretty much desert out there, although my colleagues down in Mexico don't call it desert. They think I'm crazy, but this is desert habitat. And if I am looking out into the habitat, this is what I see. But if I turn around, this is what I see. So there are perennial systems out there that are going to stay wet. They're going to be providing habitat for turtles, and you can find turtles out in this otherwise very unhospitable habitat. This would be that Baja California pond turtle I was talking about, and we find them commonly in this kind of situation, and they persist out here. Now, they tend to be much, much smaller than the average, not smaller than something at a detention basin. Sewage detention basins are always going to be excessively large. But the average, again, is about 600 grams. An adult here might be more like 300 grams. So life is harder when you live in the desert, but they still persist. And then any little creek or stream, dry, ephemeral, perennial, doesn't matter. If it's got seasonal water, it's probably going to have turtles, and I'll explain a little bit more about that later when I'm trying to help Katie with the answer to her question. This is still habitat. So this is a beaver pond in a creek. Beavers provide great habitat for turtles. The beaver dam is that little deep green section that cuts across the creek there in the lower third. And they back up this water, but any kind of creek is going to work, even if it's pretty shallow. Turtles manage just fine. But the point of this photo is this. It's not just the aquatic habitat that we want to call habitat. And I put a line up there, but that was just an arbitrary line for, just for illustration. The upland habitat is also habitat. So the turtles require the aquatic habitat for thermoregulation, for refuge, for cover. They sleep in the water, they feed in the water. All those things are important and critical, but equally critical is the upland habitat. They need the upland habitat, like I said earlier, to avoid pulse flows. So the big rain event comes through and just turns that little creek into a torrent. They need to get out of the water, and they have to have the upland for that. They also nest, as you guys are going to learn in a second, and you already know. They nest in the upland. And how far into the upland? We're going to talk about that. But they nest in the upland, so they need all that upland. Then they also move around in the upland a lot, so they need corridors for that. And you can't just give them a 10 or 20 foot wide corridor and say, we're good, the turtles can manage in that little section. Now, they may or may not be able to, but they need as much upland as you can give them. So this little yellow line doesn't mean that's all they need. It's just for illustration purposes to say upland habitat is also turtle habitat. So I'm going to move on to another section. Habitat's generally pretty easy. I mean, almost everywhere you go except the Central Valley is good turtle habitat. They don't do so well in the desert. They don't do so well in the Great Basin. But in the Sierras, in the Coast Range, in the Northern California, and the South Coast Range, you're going to find turtles if they haven't been extirpated. So I'll move on to natural history, but it's about 9 o'clock. So I thought I would give us a little bit of a break. You can get up, stretch your legs, go talk to somebody. Let's start up again in 10 minutes. So we'll start up at 9:05. So I'll take my video off, but I'll still be around. And if you have questions, you can ask them. But it's always best to ask your question in front of everybody else because everybody probably has the same question. So let's take about a 10-minute break and we'll resume at 9:05. Okay, it's about 9:05, so I think we'll try to get started here. I'm sure we'll lose a couple of people along the way, but they'll jump back in. So because I think we're going to lose a couple of people coming back, I'll just not quickly or not immediately jump right back into the talk, but instead I'm going to just show you a couple of things, and that is some books. So here's a book that I really like, and I think if you're kind of a turtle geek, you should probably have this one. It's an older book by Archie Carr. I think it's from maybe even the 50s, Handbook to Turtles. It has a natural history of all the turtles in the country. So it's a pretty thick book. You can see it has a nice summary of everything. Now, it's not all up to date, but it gives you a better idea of some of the other turtles other than Western pond turtle or pond turtle that you can look into. So if you are trapping, you catch something like a painted turtle or a Florida cooter or something, you'll have some idea of what that turtle is like, where it came from. They have range maps and stuff. The kind of turtle Bible is this one. It's really quite large. Obviously, you can see this is an older book that's been updated by Jeff Lovich, who's quite a good turtle biologist. Another thick book you can see. Another one that has natural history summaries of all the different species. This one's a little more scientific in that it gives you the citations that they're using. The nice thing is on the back it has a nice Western pond turtle, so you know Jeff Lovich was working on it because he likes Western pond turtles. Anyway, those are two good books that you probably should have if you're really, really interested in turtles. If you're not, you can look up stuff online. Just don't use Wikipedia. That big black book is probably about $100 used. Archie Carr's book is probably more like $40, new or used.
What was the name on that second book, the Bible?
Yeah, I had to pick it up here. It's The Turtles of the United States and Canada. This is the second edition. There's a first edition, you want the second. And this one is by Ernst and Lovich. So Ernst wrote the first book. Lovich came in and helped with the second book. Turtles of the United States and Canada. My light's messing it up, but there it is.
Awesome, thank you.
Those are really good books. I definitely collect a lot of books, so
Hey,
I'll
Jeff,
always... Yeah, go
the
ahead.
first, can you hold up the first book again?
There you go.
Got it.
And I do recommend the two books I showed you very, very early on, like the second or third slide, which are Species of Special Concern in California, Reptile and Amphibian Species of Special Concern in California. Both of those are available as PDFs. I probably should just send those to you guys too. What I will also send is a list of all of the known publications for pond turtle, Western pond turtle, Northwestern pond turtle, and Southwestern pond turtle. And I have PDFs of all of them. So if you find something in that list and it's separated by like breeding and habitat and, recovery and restoration, that sort of thing. If you find anything in that list you need, I can always send you the PDF. I did send the table out to everybody, so hopefully you guys have that. But if you didn't get it, let me know. I'm not going to check my other screen right now, but we'll move on to natural history. And we're going to start with predators and general threats. It's kind of a small section. Some of these things I think you guys will know already. So predators can be kind of varied for lots of reasons, but the one in the top center there is a lady that I worked with, Mary Shea, holding a trap because this is a predator of turtles. People still eat pond turtles in California. It tends to be certain specific groups of people who like fresh aquatic food, and pond turtles are pretty easy to catch, especially when they're hungry. So we become still a predator on their list. I have a skunk. If you move to the left, kind of going counterclockwise, skunks are the primary predator of turtle nests. So I came across this skunk when I was doing some nest patrols, and we're going to do this on our Sunday or Monday field visit. And you can see I spooked the skunk, but it spooked me too. But if you think about it, when it's relaxed, it's not standing so tall. Its legs are kind of crouch. It helps it crouch down. Its nose is always on the ground, and it walks around, smells out the nest, and then starts eating the eggs. So we'll talk a lot about that in the field and a little bit more later. Fish tend to, we're going to go counterclockwise. Fish tend not to be a huge predator, but occasionally catfish and bass may eat small turtles. But I've read lots of studies that say the opposite as well. So how much fish are a predator? It's really hard to say. If we're really thinking about aquatic predators, it's probably bullfrog is the worst one. Coyotes catch turtles when they're coming up to nest or moving between different aquatic sites. Otters are voracious predators of turtles. They will take legs. Typically, they'll eat the legs off. They eat the tail off for sure. If they can get it, they'll get the head. Turtles can survive having their legs eaten off. We had a turtle that had both front legs eaten off and still move 4 miles up a creek. We had that thing tagged. So although otters try really hard, they aren't always successful. And then I have raccoons here. That's another one that does nest predation, but also a big predator of the little neonates, so the little post-hatchlings. We'll talk about the terminology here soon. But turtle makes a nest. The nest is underground for a few months. They hatch out underground and stay underground for another 9 months. And then they emerge. And post-emergent turtles are super susceptible, and raccoons get them pretty commonly. So we'll talk about all those in other ways too, but I'm just kind of giving you just some general predators. These are sort of the major ones. The biggest one that we know of is bullfrog. So they eat all the baby turtles. We do a lot of bullfrog control. So we'll use a pellet rifle and shoot a bullfrog, and then we open up its stomach, see what it ate. And we're often looking for yellow-legged frogs or red-legged frogs, but commonly we find everything from snakes and lizards and birds to fish and crayfish and other things. But turtles are a little too common, I'm afraid. And that's typically the demise of a turtle population. So you'll find turtles in a site. Maybe you're surveying a site and you'll find a bunch of adults and you think, oh yeah, there's population here. But in reality, they're not reproducing, because even if they reproduce successfully and the baby turtles make it to the pond, the bullfrogs just eat them. So you'll never get recruitment. So this is the biggest threat. This will be probably the primary role we play when the turtle gets federally listed. Since bullfrogs are such a big predator on turtles, this will be something that biologists end up having to work on, getting rid of bullfrogs, so that we can promote the recovery of turtles. And then, seems kind of obvious, development's not so good for turtles. It turns out that we like to build houses near aquatic features. That takes out the upland surrounding the aquatic feature. And if you remember my habitat talk there, the aquatic habitat is really good, but the upland is mandatory. You still need upland for turtles. And what we do is cut off creeks from one another, so turtles can't walk between the creeks. They instead walk into somebody's yard or get on the road. And then if they don't get run over, somebody picks them up, makes them a pet. They move to a different state or city or county, and then they drop the turtle off because it's going to live 30 or 40 years. And by then, the family has certainly gotten tired of the turtle as a pet. Roadways are a big, big threat for pond turtles. They don't walk very fast. They tend to use the uplands quite a bit, and I'll talk a lot about that later. They're using the uplands for lots of reasons, but if you see sort of in the upper right corner, there's a big flood pool here off the side of this road. We found a pond turtle in that big pool. It was just a rain event pool, but the turtle was walking around and found it. And we did not know it was crossing the road to get there until we came back later and found it right on the road. So we rescued it, kind of moved it to an appropriate habitat. But roads are not horrible if they aren't well traveled. You know, turtle can cross the road. But two things really make the road really bad. A lot more traffic, because turtles don't know what traffic means, and curbs. So if you put a curb on a road, the turtle walks over the sidewalk or the edge of the road, drops down off the curb, and now is on the road surface, which is fine. It can walk across that. If it doesn't get hit by the car, it gets to the other curb. And if the turtle's small, it can't make it up that curb. Now it's just stuck on the road, going back and forth until finally it gets run over. So curbs are really disastrous for turtles. We talked to Caltrans about this so that they could do what they call it a rolling curb. So it's a little like a ramped bump more than a curb itself. But curbs are still going to be put in. It's just part of civil engineering, and it's just going to keep promoting more roadkills for turtles. So roads are a huge, huge threat. And then a general threat is non-native turtles. Now here's an obvious one. If you don't know non-native turtles, it may not be obvious, but this is red-eared slider. We know it for lots of reasons, but it's got a little red patch behind its eye. It's sort of misnamed because the red patch never hits the ear. The ear's never red. But we call them red-eared sliders, and when they have the red ear, it's pretty obvious. This species, among other non-native species, can outcompete basking sites, outcompete for the basking sites for pond turtles. So they all need to bask. They're in the Amididae family. So it's a group of turtles that are called basking turtles. In order to stay healthy and to thermoregulate and to digest, they need to warm up. So they get up on a log or a rock. And when this turtle's present, it tends to be a bigger turtle, and it's more assertive. It evolved with many other species of turtles, so it knows how to compete for those basking sites. So our turtle, which did not compete for basking sites with other species, just with itself, is not very aggressive, not very assertive. It has its own behaviors that it uses to be king of the hill. But the red-eared slider is really pushy, and literally pushy. They'll just get up on a log or rock and push the pond turtle right off. And they take over because they're much, much bigger. They can be twice the weight or triple the weight or quadruple the weight in some cases, much, much taller, much, much broader. And that intimidates our turtle. It's just the way turtles work. So if our turtle cannot get up and bask in appropriate areas, maybe it gets on an area that's got predators nearby because it's a suboptimal basking site, or it doesn't bask very much at all, that can really decrease the health of the turtle. It doesn't allow it to digest. It doesn't allow it to kind of cook off the bacteria and algae that will grow on the shell and the fungus. And that ultimately leads to an unhealthy turtle that may eventually die. So here's an example of a little crowded situation where turtles are trying to compete for a site. Now there is one pond turtle on this whole log, and it's not going to be an easy one to find, but if you start on the left side, there's a little turtle with its head in, then there's a pond turtle, then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 other turtles from other species. So this is the kind of photo somebody would send me, and they would say, oh, you know, how many of these are pond turtles? Now I know one is, but I don't know what the rest of them are. I can take some guesses, but this is a mix of non-native turtles all competing for this log. The pond turtle is probably last on or second to last on because it's really down there on the far edge, and is probably going to be the first one off. And this is again being this situation where they're out competing for basking sites. So non-native turtles compete much better than our pond turtle does. And one of the ways around this is, if you're managing for turtles, put in lots and lots and lots of basking sites, more than you think you need. And that will ultimately be better for the pond turtle because then it'll have choices where it can bask, and that'll maintain its health. So that is one of the restoration techniques we use. If a site is, a 3-acre pond, we might put in 40 logs. You might think it only needs 2 or 3, but we'll put in 40. So if you overdo the basking, you'll help the turtle quite a bit, because then there's no competition for these sites. So that was a small section, so I'll just kind of keep going unless you guys have questions. Great, and then just remember, you can always ask questions in the field, and my email address is open to you guys. You can ask any question at any time, and if you really know me well, you'll have my phone number. You can always text me questions too, and I'm perfectly fine with it. It makes no difference. If you're asking questions, I think we'll both learn something from it. Okay, so I'm going to just talk about the sympatric species. Sympatric means they co-occur, so they're in the same area, same habitat. But I'm going to focus on the special status species because I think it's important to know that sometimes we're not managing for the turtle, we're managing for something like tiger salamander or red-legged frog or San Francisco garter snake, and the turtle benefits from that. So if you're a turtle fan like I am, and you know currently it's only a species of concern, we can't do very much. Most of our clients are not going to want to, build a pond for pond turtles because they don't require it legally. We can use another species to take advantage of the fact that the turtle will benefit from maybe building a pond for redlegs or tiger salamanders. So I'll point out a few of these species that I know co-occur with pond turtles. The upper left one is giant garter snake. We know they co-occur. They live in the same habitat, certainly in the Central Valley where I am. Pond turtles are pretty uncommon in the Central Valley, although here in Sacramento, we get them in the Sacramento River and the tributaries and drainage ditches. So they still are here. As you go further south in the San Joaquin Valley, they're pretty uncommon, but they're still around, mostly in the sewage detention basins. So going across the top in the middle, this is San Francisco garter snake. So when I worked on this species, pond turtles seem to be wherever the snake was. The snake likes aquatic habitat, mostly because that's where it feeds. The turtle lives in the same habitat. Now, turtles will eat baby snakes of either of these species. They don't care if they're listed or not, but they're going to have to find them in water and then eat them in water. But primarily speaking, we're looking at these species as a method or as a mechanism for improving habitat features that also improve it for turtle. So going down to the right, this is two-striped garter snake, just a species of concern. And I say just a species of concern because it doesn't have a lot of regulatory authority, but it is still declining. And I think this will be listed sometime soon, or at least elevated by the state, because it is in pretty serious decline. So if we're improving habitat for the snake, you're also going to improve habitat for the turtle. Kind of more typical from my experience is red-legged frog. So now I'm on the lower left. We build lots and lots of ponds for red-legged frog. I think I've done 68 ponds, pond construction for red-legged frogs. All of them have been occupied by red-legged frogs naturally, except for one, and we just translocated them there. Almost every single one of those 68 ponds have also been colonized by pond turtle. So these two species seem to go together. We know pond turtle will eat red-legged frog larvae, but something else is going to eat them too. So why can't it be a turtle? Now, I'm a huge fan of red-legged frog, so don't get me wrong. I want them protected and preserved, but the pond turtle is not all that skilled at catching live animals. So you're not really risking too many red-legged frogs when you're in this kind of situation. Although they will eat a frog too. They just have to catch them, and that's not always easy. Tiger salamander, turtles definitely eat tiger salamanders. I've seen one on the back end of a larval tiger salamander that was trying to leave the water, and the turtle got it in time. And so they're definitely going to be eaten by them, but we do a lot of management and mitigation for tiger salamander, and along the way, we're going to help turtles. And the newest one that's going to be added to the federal endangered species list is yellow-legged frog. That's going to occur in September. If you don't know that and that's news to you, you should be aware that foothill yellow-legged frog will be listed in different distinct population segments as either threatened or endangered, and in some cases it'll just remain species of concern. That's another species that co-occurs or is in Patrick with pond turtles, mostly in creeks and rivers, but we see them very frequently in the Sierra together. So these are all species that you can kind of take advantage of, and I don't mean that in a illegal or unethical way, but you can utilize the regulatory authority that comes with these species and benefit the pond turtle along the way because they're going to co-occur. And then kind of taking a broader look at species that are uncommon, so either species of concern, threatened, or endangered. Here's a whole list of other species that co-occur or sympatric with pond turtles. And when you're helping one, you're helping the other. And that goes in both directions. If you're helping pond turtle, you're helping these species too, because if you're building ponds or clearing a creek or preserving a site for pond turtle, you're also preserving it for all these species. Now down here at the bottom, I know it seems a little weird, I highlighted it here. We have northwestern and southwestern pond turtle. I say that because in certain areas, and some of you have already pointed out you work in these areas, Contra Costa and Alameda County in particular, but not exclusively, if you're benefiting northwestern pond turtle, you're also benefiting southwestern pond turtle. It's likely southwestern pond turtle will be threatened federally, probably next round, and that will benefit the one that's not going to be federally threatened, the northwestern. But either way, it's working in both directions. So it's good to know that you can benefit more than one species, and in some cases, 3 or 4 or 5 species at a time, because you can have southwestern, northwestern pond turtles, western spadefoot, coast range newt, red-legged frog, and CTS all in the same pond. So you benefit one, you benefit them all. So in,
You mind going back just for 1 second to the slide with all 6 of those species on there? Thank you.
did I misidentify one of them?
No, I just want to get a quick look at the 2 garter snakes up at the top.
Yeah, no problem. And if I just said it too fast, across the top from left to right is giant garter snake on the left. In the center is San Francisco garter snake, so red-sided subspecies, and then 2-striped garter snake on the right. Okay, so we're going to talk a little bit about behavior, and then you see the word reproduction. Finally, we're getting to the nesting behavior. It isn't finally in my head. It's really more like, okay, I've set the stage. Now I'm going to kind of give you some understanding of the reproduction, and we're going to get into that and move right into it. So again, this pond turtle is a basking turtle, so it always has to bask. It's going to climb out on different kind of wooden structure or rocks or the muddy shoreline or an old cow. We've seen them on tires and, you know, submerged cars and things like that. They don't care what they're getting out on, as long as they can climb up on it. They're going to get on it, and you'll be surprised what they can climb on. Some pretty slick and rounded stuff they can get up on. So here we are, the couple of little turtles sitting on a tree. They're going to do this in the morning, so they have this bimodal basking behavior. So somewhere around, on a day like this, somewhere around 8 in the morning, they're going to come out and start basking. They'll get back into the water a few hours later, feed for a while, and then later in the afternoon, they're going to get out again. So there are prime times to look for turtles where you're more likely to see them, and that's going to be not early in the morning, but in the morning, so before noon, and then somewhere around 3 or 4 or 5 o'clock. So they're trying to warm up before they hit the water and go to sleep. So if you're out there looking for turtles at 1, you're less likely to find them. So if you're given that task to go find turtles, don't pick after lunch unless you're going to pick really at the end of the day. So turtles will bask based on their, I was saying this earlier, based on sort of their ability to tussle with another turtle or each other. These are both pond turtles here. They'll shove each other around if they don't like the position, open their mouth and threaten each other, but that's about the extent of it for pond turtles, where all the other non-natives will just ram the other turtles right off and take the spot over. So even these little branches that are sticking out of the water are important, and you don't want to just, you know, kind of clean or clear a creek that might have lots of woody debris for the sake of beauty or for the sake of navigation without recognizing you're going to reduce habitat for pond turtles. So if, like the Sacramento River up here, it's a navigable waterway. They run enormous ships through it, and occasionally the county will come out and try to clean up some debris, but they pile it up on the edge of the bank, and that works just fine. So if this stuff is just floating around in the river and they push it to the side, that'll work for pond turtles too. But if you remove it all, and this happens with flood control districts, they're really prone to just removing all this debris. That does really, really decrease habitat value for pond turtles. So kind of keep that kind of stuff in mind too. So, Katie, you popped up. Do you have a question?
Oh, I guess I was gonna ask, you said they're not very common in the Central Valley, but does that include like rivers like the Sacramento River or?
So they're not so common in the Sacramento River itself. They're common in the tributaries. So the tributaries might be big rivers like the American or the Mokelumne. And they're more common in those rivers because they're a little bit slower. But because we regulate the flows on the Sacramento and the major tributaries, the water tends to be pretty cold. So there's lots of details behind all this, but when you build a dam, when you release water from the reservoir behind it, you're releasing it from the bottom. And that water tends to be about 55 degrees. And that's too cold for most turtles. So they'll move out of those river systems and move into ponds adjacent to the rivers or little backwaters or little oxbow lakes, or just drift down the river until they find a warmer patch that's a little bit better. But they don't do so well in estuarine sites that are kind of salty, although we found them in the San Francisco Bay. We know they're in the estuary too. They can tolerate going into the ocean, so they will swim down a river, come out of into the ocean and swim up another river. We just don't see them in the numbers we would like to see them in the Central Valley. We find them in massive numbers in sewage detention basins in the Central Valley. And
Okay.
somehow they find those. You know, they're not always associated with a water system, but they find them anyway.
Okay, thank you.
It doesn't mean to say, you know, they're absent. It just means you're going to have to look harder. And that might mean, as a consultant especially, you might need to rent a boat and drift down the river a few times looking for turtles, as opposed to just walking to the shore and using binoculars and scanning. That's just not going to do it. So here's a little turtle doing its thing. You know, it's sort of mid-morning. It's feeding in vegetation because they eat lots of vegetation. While they're feeding on vegetation, they're probably also taking in lots of invertebrates, which help them to grow faster because that big pulse of protein. You can see that this turtle has lots of little anguli on its carapace. So if you look close, I can count the rings to tell you how old this turtle is. And if I'm going to do that just really quickly, I'm going to say 1, 2, 3. This is about 6 or 7 years old, but the turtle was only about this big. So not a very big turtle for the age it was, but about 5 is reproductively viable. The problem is if you're that small, you're not going to compete with other turtles. So there are lots of things about turtles we can talk about in the field, and I'll talk a little bit more about that piece too. So turtles basking on the surface of the water, so the water surface is very warm, and it's also feeding. Now turtles are predators too. So guy I know, Brian Hubbs, Hubbs took this photo. This is a turtle eating a non-native crayfish. They will obviously eat underwater. This one found something that it wanted to prey on, and it preyed on it. Now crayfish can be pretty fast, but I imagine this turtle just climbed under a little crevice or a rock or something and grabbed this crayfish, and it's going to eat as much as it wants and then leave the remains later and come back for more. But they eat lots of other things too. I've seen them eat, and I have mentioned this before, tiger salamanders, fish. They eat lots of carrion. So like when we trap, we might use a roadkill ground squirrel or just some fish we buy from the frozen section of the grocery store. So protein is really something they desire. And if they find a dead duck or bird or snake or anything in the water, they're going to eat it for sure. They eat lots of remains from otter kills. So otters will kill things that are much bigger than they can eat, then they leave the rest behind and turtles come in and feed on it. They also eat amphibians. So this little toad is not the specific toad I found, but I found a toad just kind of bobbing in the water and wondered what was up. So I went and picked the toad up and there was a turtle hanging off its leg. So toads don't move very fast. That's ideal for turtles. But they eat lots and lots of different animals. They don't really care what the size is. If a dead cow is in the pond, you'll see lots of turtles feeding on that too. So getting outside of the aquatic feature, and I'm heading closer toward the topic that we really want to focus on here, turtles do move around a lot. So this is a turtle I found just walking around at night. That's why it's got a little light on it. It's got a flash on it. This turtle was moving around, and then I noticed that it's got this little muddy rim on the back of its carapace right here by the tail. So between its two back legs, you can see just a little mud ridge. That tells me lots of things. First of all, I know it's a female because I don't have to pick it up, but because I know it has this mud on it just where it's at. So that mud comes from building a nest. So I know it's a female because it built a nest. I know it nested because it's already done and trying to head back to the pond. I know it's a reproductive adult, even it doesn't matter if I measure it or weigh it. So I know a lot of things really quickly just from seeing this little mud edge. I also know that turtles aren't very excited about being out at night, but they will be out at night when they're nesting. So I suspected when I found it, it might have been a nesting female. So I ran up to take a photo and saw that mud edge and thought, oh yes, she already nested. I wouldn't know where the nest was, and we'll talk about that for sure. But the idea is, yes, I have a nesting population of pond turtles at my site just from this one observation. So if you're lucky to find one nesting during the day, here's a pond turtle female nesting. So she's in some grass. She has walked up in this grass patch, and I'm going to just speak about this generally, but I'll get into more specifics in a minute. She walked up into this grass patch. She started to dig a little bit, and then she'll urinate and then dig, then urinate and dig, urinate over and over and over. And so that what she's doing is softening soil that is otherwise really very, very hard. It could be that kind of hard soil that if you try to throw a pick at it, you're using a pick to dig into it, it just bounces off the surface. Turtles can still dig through that stuff, and they do. They have trouble with a few things like stones or roots or stuff like that, and I'll show you a photo of that in a minute. But here's a turtle just digging a little nest hole. You would never know it was there except that I was looking down. I wasn't looking at my phone or talking to anybody. I was looking for turtles and found this one just nesting in this little grass patch. And if everything goes well, you'll end up with a little pond turtle like this. So all of these photos I've showed you are pond turtles in the upland, and that'll be another topic that I'm going to end with, because turtles do spend a lot of time in the upland walking around looking for nest sites or nesting or moving between ponds. And then if you're a little turtle, you're in a nest, and I'll talk about the timing in a minute, but you're in a nest for a very long time, about 11 months, and then you pop out and you're not able to get to water right away. We'll definitely talk about that. But they spend a lot of time in the upland because they're tiny and they have to move between a nest site and the water. So keep in mind that pond turtles do spend a lot of time in the upland. So I'm going to go into that through a chart. So I'm using this annual phenology or timing of pond turtle natural history. And it's very, there's a lot of these little schematics that I put together, but it's going to try to paint a picture of how much time pond turtles can be in the upland when they're nesting, which life phases available at the time that we're going to talk about. So as we're going, before we jump into the little charts, I'll show you just a few pictures. And I have this calendar on the bottom. It goes from January to December. That's just us. That's the way we look at the calendar. But it works for pond turtles. So I highlighted the section of time where I'm talking about. So in this case, we're talking about adults are becoming active after the winter. If it's a very cold winter, they're not very active. So now they're becoming active and they mate. So turtles mate in the water. They don't mate on land. They can't mate on land. They need the water for buoyancy. So they're going to mate in the water. Believe it or not, these turtles are just resting on a little platform I put out there, but there's so many, they made it sink. So this is very late February to around early May. Turtles are active, mating with each other, and then going back, like the males just move on to the next female. The female stays in the water, starts taking on water, so she's drinking a lot during this period, and really building up an enormous, essentially an enormous bladder bubble of water. So when she gets on land, she could use that to help her dig. So we're really talking about timing here. So look at the bottom. This is the period where females leave the pond and lay their eggs. So around mid-May to around mid-July, the female turtles will get up on the bank, usually in the afternoon. They look around, see if there's a predator around, and then they move up into the upland and they'll start searching for a place to put a nest. They'll dig a little, and if they don't like the soil because it's too rocky or too hard or too soft, or it's too shady, they'll move on to another site. They just move around. You'll see them in the upland quite often this time of the year. This is when people will be mountain biking or walking their dog or driving and find a turtle just out on the road or on a trail and think it's lost. But this female has made, this extraordinary effort to leave the aquatic site, might have walked several hundred feet or even 100 yards, and has, avoided lots of predation events or getting run over, and somebody finds it, takes it back to the water. It's got to be really distressing for the female because she's got eggs. She needs to build a nest and lay those eggs, but now she's returned to the water and she'll have to do it the next day. But this is the time period where we're most likely to find nests and nesting turtles. That's why I picked June for our workshop. So again, here's another female. Now we have a telemetry unit on this one. I'll talk about that in a minute, but it did not help us find the turtle, except that I painted it red. I painted every telemetry unit a different color, and we could see the red in the grass. That was the only beneficial aspect to this. But I'll talk a little bit about nesting and why this is a problematic issue for us. So here's the turtle. She moved into the grass. She is going to start nesting here. If I pick the turtle up, this is what you see. A little wet spot where she's urinated. She starts to dig. She finds it a little bit soft, so she's going to make her nest. The nest itself now is going to be planted in the ground. So she's going to dig a nest about 6 inches. She's going to drop these eggs in there. And then she's going to take the dirt that she used to dig the hole and grab it with her feet and push it all back into that hole and pack that down. And it's going to be packed down with not only mud, but grass. And we call that a cap. So the nest will have a cap on it. And we'll talk about this in the field. Hopefully we'll see some. And then she's going to mask the nest with grass. So she'll push grass over it. And it makes it very hard to see. So now there's going to be a nest in the ground. And this is in June. Usually, sometimes in late May, but often in June and July. And the eggs are incubating underground under this little cap. So they're about 6 inches down, usually in a sunny spot. And if the eggs on the bottom are cooler than the eggs on the top, so there's 2 layers of eggs, the eggs on the bottom will be male, and the eggs at the top will be female. So she has dug a hole that is in the sun so that the warm eggs at the top will be female, and the ones that are on the bottom, because they're further down, are going to be male. So she's got a bunch of eggs in a nest, maybe up to about 8 or 9, and they're going to be in the nest until about August. In August, these little eggs will hatch underground, and they'll stay underground. So they're not hatching and coming out. Now, if you live in maybe Orange County or south, you might get some turtles digging out of the nest in August or September. But for the vast majority of the range, the eggs hatch in August. The little turtles stay underground and stay in the nest, and they just stay down in there, not doing very much. They're feeding on a yolk sac they have. So if you progress through time, what you see is, if you dig one up, and we did, you see the little turtles in there. Now you see a turtle right here on the left of the hole, and just next to its head is an egg. So not all the eggs hatch. Sometimes you'll get some that hatch, sometimes you don't. Sometimes you'll get, like, a gopher will come in, intersect that nest, and eat everything. Rodents eat protein. So the point, though, here is that the turtles are active underground. They're alive and moving. You can see another one's head on just below the carapace of the first one. But you have a clutch of eggs that aren't hatched and a bunch that have hatched. And they're just living in that little hole, kind of moving around slightly. And as they're moving around, they're kind of wearing away the top of the nest cap. And they're just slowly pushing, wearing away as they're moving. And again, they have a yolk sac, so they're feeding on that. They don't need to eat. And then at some point, you get these little, ignore the left side and just look at the right side, you get these little turtles to emerge. So these are not hatchlings. A hatchling would come out in August. These are post-emergent turtles. So you can see this one's sort of bent down. It's like a little taco shape almost. That's a really fresh turtle that just came out of the nest, and it's trying to move to the pond. But this is also a time when if we're doing these little nest surveys, what we see is predated nests a lot, and that's what's on the left. So you might see hatchlings, not hatchlings, post-emergent turtles. You might see these predated nests. So you'll walk around where a skunk found a nest. It dug out that little cap, that little plug, and then it ate all the eggs and left them behind. So we're probably going to see a little of what we see on the left. We may not see anything like what we see on the right, because that's going to be more like March or April. If we're lucky, we'll get one, but we'll have to be pretty darn lucky. So you can see the time has progressed. So again, we're going to just run through that really quickly. May, June, July is the nesting period. August is the hatching period, but they stay underground. Then you wait all the way until March or April, and sometimes early February, for those little guys to pop themselves out of the hole and come out onto the upland and start moving around. So here's a site that we'll go visit. This is actually a site I worked on. It's going to look very, very different when we get there, because this is about 5 years ago when we did a restoration of these pools. But if you look all the way to the left there, I'm sorry, to the right, we're going to presume that you guys can see that there's a little round red dot down there. That's the nest site. So the nest site is the red dot, and a little hatchling comes out of that. Not a hatchling, a post-emergent turtle comes out of that. And in one day, it's going to make it a couple of meters, maybe 5 meters. So it's not going very far. Sorry, I just saw that there's a question in the chat. It says, is there a temperature threshold for male versus female? Yes, there is. And there was a paper that was written. I don't have it memorized, and it was in centigrade. So, you know, that's hard to calculate for me off the top of my head. But there is definitely a threshold. So I would have to look up that paper, but I have it, and I'll look at it and have that information ready for the field. So we'll do that for the field. So the red dot is where the nest is. And in one day, the turtle makes it 1 meter or 2 meters. Now it's just sitting under a tuft of grass. So it's come out of the nest, and in one day, it's made it a couple of meters. So if we go a little further along, the next day, maybe it comes to this tuft of grass or this patch of dandelion or starthus or whatever. And as you progress through time, the turtle makes it just sort of zigzagging along. This is the little baby turtle now. And it takes it a little bit of time to get all the way to the pond. Now, if you can imagine your little turtle about 1 inch, you actually have quite a distinct smell, and I would call it a stink. It smells like rotting animals, and that comes from the fact that they lived in a nest underground for 4 months on top of waste material and dead eggs and things like that. So they have quite a smell. So they're trying to make it just a little distance, and in this case, it's only about 30 feet. But in most cases, it's going to be about 200 feet. And that little turtle, it might take a couple of weeks to get to the pond. Now, obviously, it's not eating during that time because it has to be in water to eat. But this is a really, really very vulnerable time for a little turtle. It can be stepped on. It can be eaten by anything. It can fall into a little hole in the ground and just never be able to climb out. It can go in the wrong direction and never find the pond. Lots and lots of things are against these little tiny turtles. So nesting turtle is one thing. So you have a female that makes a nest. That's successful nest creation, but that doesn't mean you're going to have recruitment, because these little turtles have to make it to the water and then survive the bullfrogs and fish and otters and lots of other things. So if you're lucky enough to get one, they're very, very hard to find. Here's about the size of them. This is my hand. So they're about the size of a quarter, which is 1 inch, not very big. On the right photo, you're seeing the plastron. You see that little kind of decaying tissue there. That's the connection point to the yolk sac where they were feeding, within both in the egg and then outside of the egg. That's a little stored energy for them. So when they're underground, they can use that energy to survive. So very, very hard. It's super hard to find something this small out in the uplands when they can just hide under a leaf. But it's also very easy to mow one or step on it or drive over it. So you got to keep all that in mind too. Given a couple of days, the turtles kind of harden, and here they are. If you are lucky enough to grab some, they're still very small. They're looking for some place to get to the water, but you know, a cow patty can stop their progress. or a patch of cattail, or you know, a restoration project. You put in a bunch of plants, and all of a sudden you put in a barrier to turtles. And this doesn't even count things like curbs or sidewalks or people or dogs or cats or whatever. Okay, so now we'll get into nesting surveys. So this is the kind of thing you guys probably do. You're probably tasked with this as a job, and you are told to go out and look for turtle nests and protect them because we're going to start a project next week. And you don't truly know what to do, so you go around looking for nests and you don't find any. And you say, "Well, I didn't find any nests," and everybody's happy. But there's lots of pieces to this that I'll talk about in the field too. But I'll show you what did and did not work for us. So we started with the idea of trying to find nests. So we got these GPS telemetry units, and they tell you where the turtle is, whatever increment of time you want. They're pretty big, so you need big turtles. They're pretty expensive. They're about $3,000. I think these were $3,200 each. You needed a unit to read the data. Then you needed people out there to collect the data, and you need people to analyze the data. So it cost us about $60,000 to try to figure out where turtles nested using these units. And here's what we got. The unit will tell you where the turtle's going, how many times it goes there, where it stopped, and all that's great information. But what we were looking for was nest sites. So we found these little points where the turtles got onto land, and we thought, okay, there's going to be a nest there. But this is the same turtle. So there's 1, 2, 3, 4, 5, 6 little red circles here where we knew they went to an upland site. And it stayed there for some period of time, because you could read through the data and say, okay, that turtle was there for 47 minutes or 2 hours or whatever it is. So we go to those little spots and we're looking around, and we know from the map, we have the map on our tablet, we know we're right on the spot, but we can't find anything. Because remember what I was telling you earlier, the turtles will build a nest, they plug it up with mud and a little bit of grass mixed in, and then they grab some grass and with their back legs and push that onto the nest, and the nest just goes away. Once it's dry, so all that urine stain dries, you're not going to find it. We couldn't find them. We've been doing this for many, many years in a row. We knew with the GPS units where they should be. Now, this is one turtle, and it had 6 spots. So these might have been like exploratory nesting areas. She was just trying to find a good nesting spot. And maybe one of those was a nest site, but we still never knew. Because even though we had a spot about 1 square meter and we're on our hands and knees pushing through the grass, we couldn't find the nest. So using GPS, which is the best technology we have right now, we still could not find the nest. So instead, what we decided to do was go out there with people and just sit around and watch. And that's part of what we'll do in the field as a group. So we were watching for turtles. We start about 3 in the afternoon. The females start coming up on land. And if you're in a good spot or you're walking around and you are lucky, you intersect a turtle that's coming up on land and you watch the turtle from a distance. Excuse me. You watch the turtle, it'll make its way to a spot it wants to nest. You'll watch its behavior. You can see it's urinating, then it's digging. You can watch that behavior with binoculars or a scope. And when she's ready and done with her nest, you can watch the whole process. It takes about 3 to 7 hours. So be prepared to have overtime approved automatically. You run up to that location. When she's starting to walk away, you run up to that location. And I mean run, because if she's more than a meter away from that little spot, you're not going to find it. You get on your knees, you start pushing grass around, you look for a little wet spot. Okay, you put your pin flag in, now you put your fence around it. But this takes lots of people, lots of hours for lots of days. We did this 7 days a week from about May 15th to July 15th. And every year we'd find about maybe a dozen nests out of about 75 females that were nesting. And we would spend hundreds and hundreds of hours doing this. So imagine that compared to maybe you being told, oh, we're going to put in a culvert crossing or fix a bridge. You go out and make sure there's no nests for turtles out there, and they give you a day or maybe 2 days. You're just not going to find them. It's just not going to work. And we'll talk a lot about that in the field. So,
Hey, Jeff,
yeah.
I have a question. With nesting pond turtles, is it something that you can look at, like if they repetitively come back to the same area to nest again?
Yeah, so that's called nest fidelity. So nest site fidelity means that if a turtle nests in one site, there's a high likelihood it'll come back to the same site and nest again. But that nest fidelity is not very specific. So it might be a 10 meter by 10 meter patch that it likes, and it's been going there for 30 years. But where on that 10-meter patch, you don't know, and you don't know if you find one nest 1 year, which direction you should be measuring, to save those 10 meters or 20 meters, or for that individual turtle, we don't even generally know how big that patch can be. We also know if a turtle is disturbed, even on its preferred nesting site, it will go to a completely different site to nest. And completely different will be, 1,000 meters away. So you might be protecting a site where you see a turtle nest 2 or 3 years in a row, but now it's a half mile or a mile away, nesting somewhere else, and you didn't have any idea. Maybe that's out of your project area, so you don't care. But for the most part, you're doing that with lots of turtles that are crisscrossing all these little areas, and quite honestly, you just don't know.
Okay.
I know that's
Thank
not the answer you want. I do. I am very aware of that piece. And it's part of what I'm kind of showing. So we worked on these turtles at this site that you're going to go to for 12 years. And I still can't tell you where they nest.
Okay.
And we were out there every nesting season with a large crew. They're from 3 o'clock to about 8 o'clock at night. And we're just getting about 10% of the turtles with that effort. And so the other 90% of the turtles are still making nests wherever they want. It's a little bit of the point I'm trying to make, actually. But we
Yeah.
can kind of confirm that in the field. Okay,
All
so sorry. It's a great question. I really appreciate these questions. And I know the tendency, and I have the same tendency. I'm going to go to a workshop in a couple of months, and I'm going to have specific questions too. And I'm going to be unhappy when I don't get the answer I want, because we need help to manage the turtles. And it's going to sound like I'm not helping you, but in the end, I'll show you what you need to do. It just won't be what you want to do. So, okay, we're doing all these visual surveys, and you guys will do that with me. So we find a turtle. The female climbs up the bank. She, goes and looks for a nest site. And here's an actual turtle moving along. I'll put a little arrow here so you can see it. This is a turtle that came up out of the pond that we're going to go to. It climbed under a fence, went across the little grass patch, across this little gravel road, up a hill, and into a pond on a neighboring property, and then came back to our pond. So it nested somewhere else, and we don't have any idea where, because it's on private property. So turtles go where they want to go. And this is probably because of our presence. They know we're there. They can see us. They're super good at seeing you. So that does remind me, in the field, try not to wear red, orange, or yellow. Turtles are sensitive to those colors. Now I'll forget to remind you, but see if you can remember that one. Because somebody's going to wear red, and that's going to spook the turtles. But we'll manage it. Don't worry. So anyway, this is a turtle that just wandered off and nested somewhere else. Came back with a little mud rim on her carapace, and we're like, oh my God, where did that thing nest? It's on private property. But the turtles on the private property on the pond over there might be coming to our site and nesting on our site. We don't know. They crisscross by choice. So here's a turtle nest site. Excuse me. So a turtle came off, started digging this nest. This is called a nest scrape. So she urinated, dug a little bit, and you can see some rocks in there. And she just thought, she's not seeing it, she's feeling it with her back legs. She's only digging with her back legs, and just rejected it and wandered off. She wandered off back to the pond and nested the next day. So she did not come back to the site. She went to a different site. Obviously, I took a photo of this, so I was there. And she probably saw me and just thought, yeah, forget it, I'm not doing it. So the arrow is pointing in the direction that the female's head is pointing. So you kind of learn turtle nest sign and the direction they were pointing. And the direction matters because when she's done, she's going to race in that direction back to the water. So here's a nest start that actually dug a hole. So she did the urinating, digging, urinating, digging. And on the backside of my hand there is the pile of mud she's pushing up. So she's going to be using that mud to fill the hole back in later. Oops. Oh, that's the same hole. So I want to show you with my hand out of the way. The hole is pretty small, only about an inch. But inside that chamber is about 4 inches around. So it's a big, it looks like an upside down light bulb, but nobody uses light bulbs anymore. So it looks like a fist space underground with a small hole to get to it. And it's about that size. So you can see the big urine stain, the big mud pile, and this turtle was pointed in the direction of the arrow. And we know that again because that's the direction she ran. So she just started digging this, and when I put my finger in there, I could feel a root. So this was a start. She spent about 3 hours doing it. We watched her the whole time, and she just abandoned it because she hit a root. So they're going to go through this phase a bit where they start nests and aren't able to complete them, and they just come back the next day. The problem for us is we think, okay, she liked this spot, she'll probably come back, and they don't. They just go to the other side of the pond and dig a nest in the flower garden or wherever they choose. Some of this stuff, these kind of nest starts are a benefit for the turtle because they all smell like turtle urine, and the skunks coming by focus on them. And then when the turtle moved to a different site, its nest is protected. Then also keep in mind that all this debris, you can see kind of debris pile like grass mixed in the mud, all that's going to become the plug that she patches back in. And without even looking, she'll reach back there where you see this funny little green leaf and these grass fragments. She'll grab those with her back legs and cover that whole nest, and you won't even know the nest was there, even minutes after she was there. So here's that turtle again that I was saying earlier. It's digging a nest. Here's the direction of its head. It's got its head tucked in, but I just drew a little goofy turtle head here, just so you know which direction she's pointing. I moved the turtle off the nest. So believe it or not, this is the turtle's nesting location. So the rear end, the turtle egg laying end is on the right side. So I'm going to move her to the right. So I've shifted her to the right, and now you're looking in front of her. So to the left of it is the nest site. So she's completed the nest, covered it up, brought the grass in. That's the nest. And I show you that to say and really emphasize, I mean, I want to shake my fist in the air. This is a nest. After she's done, she's going to walk away, and you have to find that. And you just can't find these things. The only way is to be on your hands and knees, grabbing through the grass, pushing the grass around. Now, I'm going to answer a question that we're probably going to get anyway before you even ask, and that is the use of dogs. So what about using dogs? Can we use dogs out there? Yes, you can use dogs, but remember the turtles are doing nest starts everywhere. They're doing abandoned nests that they start up and they just leave. They're urinating, just sampling soil. So if you marked every spot where a turtle urinated, you'll have 300 or 400 flags out there, and it'll cover your entire site, and you'll be protecting everything anyway. So dogs just become ineffective in this way because to train them, you have to train them on turtle urine. You can't train them on turtle hatchling smell because that's only a certain time of year when they're in the ground. And so they're finding turtle urine. They're not finding the nest. So it doesn't work the way we had hoped. We tried really hard, but it didn't work. Yes, here's the nest spot. And actually, when I was looking at my own photo doing this lecture, I had a different memory of where that turtle nest was. So I'm glad I had this drawn. That's how hard it is to find. They're not easy to find. You got to find the turtle. Now, when I drag all that grass away, here's what the nest looks like when it's done. So packed down. I mean, she really packs that down. And unless that's wet, you're not going to know that that's a turtle nest. You walk right on by it. So it's a very, very, very difficult thing to do. But we'll work on it. I'm not leaving you hanging here. We'll talk about this stuff. So again, this turtle walked in that direction. And again, it always matters because she's going to run to the pond to avoid predation. Because now she's got this big smell of the nest there. And this is when something like a coyote finds them up in the nest sites, and they just run right back to the pond. So here's that turtle again. Again, if you find a turtle with a big dirt crescent on the back of the carapace by the tail, or you can even look at the feet and the tail, they're both muddy. You know that is a nested turtle. That's what we call them after they've made a nest, a nested turtle. There's that mud. So when we come along, this is the very same site, and we find a nest, which is not always common. We put these little cages over them and protect them. So this cage has a big apron on it because animals will try to dig under. We use these enormous spikes because they'll try to pull the screen up. And in the center of this little screen, you see a little raised patch. It's not easy to see here, but there's a little raised patch in that screen. And that raised patch actually has a different kind of mesh in there so that when the turtle hatches out, it can just walk right out of that little cage. And we don't have to be there the moment they hatch. So they can release themselves on their own, but we will monitor them. And when you're monitoring, here's like, several months later, it's now winter and grass is growing through the nest and you don't know where the nest is anymore. So this is a photo of the same kind of nest structure, and we're looking straight down on it, and there's a nest kind of in the center there. And when you get really close to the nest and then also close to the hatching, they make a little air hole. This is really just they're moving in the nest and they're wearing the roof of the nest out as they're going up. And eventually it makes a little little air hole. And if you put one of those little cameras down, they have these little fiber optic cameras you can put down in there, you'll see little baby turtles moving around. This is a very vulnerable time for the turtles because that air hole means they could be smelled by a predator. Predators just dig this up, eat the little turtles, and move along. So we keep these little cages on top of them, but finding that little air hole is tricky. That's about the size of a pencil, and you're not going to just if your company sends you out in this photo was taken in February. If they send you out in February and say, "Oh, go find turtle nests," because we're going to be starting construction soon, and you're hoping to find these little air holes and find nests, you're just fooling yourself. You're not going to find one. Even if you hired me and everybody that's worked for me in my entire career on this project, we would find zero. This is not the time to find turtle nests. The time to find turtle nests is going to be in May, June, and July when they're being made. Again, there's that air hole.
Jeff,
Yeah.
if you find a hole like that, is there a way to tell the difference between that and a small mammal burrow, just standing there looking at it?
Well, a small mammal burrow hole might be this big, and a turtle breathing hole is going to be about this big.
Oh my gosh. Oh, okay.
Yeah, like size of a pencil, really. Like not the length of a pencil, like the width of a pencil, like
Oh, okay.
that.
Okay.
So it's more like a beetle hole or a worm hole.
Oh gosh.
And there might be 10 million of those out there.
Thank
So
you.
now here's the same nest. Now this is about 2 weeks later. We pulled the screen off, and the turtles are moving in that. Remember, they're moving in that nest, and they're kind of wearing the top of the nest out as it's going up. So it's a little like sanding the top of the nest. So as they rub and erode the top of the nest, that dirt's falling down under them and it's pushing them upward as they're moving. So it's this incremental movement. And you can see the top of the shell of this little turtle that is going to be a post-emergent turtle in minutes. We just happen to stumble on it at the right moment. And it's going to pop out and fall under a piece of grass or leaf and just sit there for a day. And if you're walking by, you're not going to find that. You just won't. Now, I have a dog here laying on the floor next to me that has a nose that is really annoyingly good, and it might find one turtle, but it's going to find, turtle poop and turtle pee and lizard poop and everything else too. So it's just it's really luck to find it. So we know it because we knew where the nest was, but this stuff is as frustrating for me as it is for you hearing it, trust me.
Hey, Jeff,
Yeah.
quick question. So I know it sounds kind of silly and we mentioned it at the Rare Pond Species Workshop, but what are the chances of training skunks to sniff out amniotic fluid?
Well, so two things right away. I think in Florida, you could do this because you could have skunk as a pet in Florida. In California, they're illegal because the Department of Agriculture sees them as a pest due to rabies, and the Department of Health also has restrictions on turtles. So you don't have to just get the pest CDFW. You can get a skunk in Florida and come to California with it as a pet and get a permit to keep it. So yeah, you can have that, but getting through those other humps of the Department of Health and the Department of Ag is really going to cripple you. So it would be problematic. But let's say we don't have to worry about permits and we just grabbed a skunk and trained it to find turtle nests. It's going to find a lot of nests. They already innately know there's a scent there that means food. So they'll find the eggs for sure because they can smell the turtle urine. And skunks will dig constantly all night long. So they'll sniff something, dig a few digs, and they don't get any more. They move on to the next spot. So they're testing constantly. When it comes to the nesting time, these things stink. They're just rancid. They smell like a roadkill. Yes, you could probably train a skunk to find these things if a skunk was smart enough to be trained. That's another workshop. There's probably a solution at this level. Like I could train my dog to know the smell of this stink of a turtle. If we had a little hatchling, I tell you, they stink badly. So I could train my dog on this level, but that means you're only going to find turtles in February when they're really close to the surface. And that's not when your project's going to start. Your projects might start anytime out of any portion of the year. And you're giving, 2 weeks notice or whatever. So we're really dealing with nests that are in the ground that are just sitting there. And how do we deal with that? And I'll give you some idea, but your questions tell me the very thing I think about all the time. How do we protect these things? How do we find these things? And I'm not leading to like some big, ding. We're not going to get like, oh, Jeff just solved everything for us. I can, but none of your clients are going to like it. And we'll definitely get to that. So if you dug them up, here's what you would find: a bunch of turtles in there, maybe a few eggs. And then the turtles try to make it to water. And once they're in the water, they're kind of on their own. They have no protection from anything. Green herons are really a big predator at this very stage. They'll eat these baby turtles in a second. Anything like an egret, a heron, otters, fish, snakes, bullfrogs. Bullfrogs are the worst, obviously. Everybody's going to eat these little baby turtles. So getting it from this size, which is, if you count it from when the egg is laid, this is an 11-month-old turtle, even though it just hatched out the same day. So we don't really know how to age these things. A hatchling starts in August, so if we count it from August to April, that's about how old this thing really is. It's a tiny turtle, doesn't matter, about an inch wide. So very vulnerable, super hard to find. When, like, I released 5 of them together and put them in these cattails, and I went back to the shore to get my camera and came back. I was lucky to find 2. They're just so hard to find, even though you know where they are. And the shore in this case was like 2 meters from me. I could just lean over, grab my camera, bring it over. So very, very tough. So these are some of the ones that I had released, but they're very hard to find. So very vulnerable, very tough. But these are super, super, super cute animals. And when you handle enough of these, you really do become an advocate for them and want to help them. And my goal is not necessarily to kill every skunk or every heron or every bullfrog, but really to see if we could educate us to figure out what to do about preserving these sites. And I definitely will talk about that stuff as we move forward. Oops, sorry, going the wrong way. So we're going to talk about turtles in the uplands, but I'm going to give us another break because we've been going for about an hour. We'll just take 5 minutes here. So it's 10:15. We'll go to 10:20 for a 5-minute break. We'll talk a little bit more about this, and I'll get to the solution. It's just not going to be an easy one or one that anybody feels all that good about. But there is a solution to all this, and we'll talk about it. So we'll be back in 5 minutes, so 10:20. So it's about 10:20. We're going to get started. And I know that some people just kind of straggle back in or they're checking their email or whatever, but we're going to move along so we can get through this for you guys. And I'm integrating this into the nesting ecology because it has a lot to do with the nesting ecology. But I'm also talking to you about turtles in the upland in general. So the way to learn about turtles is to do lots of visual encounter surveys and spend a lot of time in the field. And that's not really the way consulting works. The way consulting works, and I'm a consultant, so I get this, is, time is money. We give you not very much time. Somebody else is deciding how much time you need, and then you got to get it done and get back and report it and move on to the next project. And I get how all that works. And I'm not even saying that that's bad, although in a different conversation, I would say that that's horribly bad. But for this conversation, what I'm saying is, think about the turtle's lifestyle. It lives about 30 to 35 years. I think the oldest one we now know that is living is 36 years old. It lives a very long life. It does things very slow. And so we have to think in that same way. We have to think slowly when we're doing this stuff. So it's not really conducive to consulting. Consulting is not slow. It's all about fast. So what I'm going to share with you, though, is what should be done. And that means not only by you, but by me and by other people who are trying to figure out how to protect turtles. So you got to get out and conduct as much field time as you can and do surveys, because all these sites are really site specific. So my site that I'm going to take you to is one of my sites. I have about 8 sites that I use, but this is the easy one for turtle nesting. Others are much more difficult. So I'm going to show you the easiest one I have. And what you need to know is your site is probably going to be harder, and so are all my other sites. So lots of time in the field really matters. So here's a site where I was at in the Sierras, where I'm just walking along, and this is literally what I found. These 2 turtles were just sitting on the land. Excuse me. This was in May. They're not doing anything. I can see from their shape they're both males. So I pick them up, look at them. I confirm they're both males, but they're just sitting on the land. And why they're doing that, I'm not really sure. I can't really tell, but they use uplands for resting, for refuge from habitat that might have fish in it, because fish will hassle turtles. If there were otters present, otters are more likely to be in the water, so they might get on land just to relieve themselves from that pressure. But turtles use the land too, and that's generally my point. And not just for nesting, but we're going to try to integrate nesting into all of this stuff. So here's one thing that I've reviewed, and I still find a little bit surprising. So here are 7 authors, including myself, who have done research on pond turtles and research that relates to their use of uplands. So how much time do turtles spend in the uplands? And that might be an individual turtle or groups of turtles. So Reese in 1996 found turtles stayed at a maximum of 122 days on land on Reese's sites, which were river sites. So lots of pulse flows, winter weather that's really cold in the water with lots of flush flowing down the river. The turtles just get out and spent up to 4 months on land. Holt did work in Oregon and found a similar time period, about 3.8 months. Rathbun found turtles in the central coastal area of California using land for up to 6 months of their year, which is half the year. So they're not eating for half the year. But then we get into like Bondi. Bondi did work and found some individual pond turtles would spend as much as 10 months of the year out of water. Now that's not every year. They're spending time out of the water. Some years are going to be drought years, and they might be out of the water 10 months during that one year because it happened to be a drought year. Pileoid, if you read any of these papers, this is a really good paper about upland habitat use. About 7 months of the year were spent out of the water, and this includes time when water is present. So they had turtles that were using stock ponds. Stock ponds maintained water year round, but the turtles would leave and go into the uplands and just wait out the summer because maybe the water was too warm or there wasn't enough food. We don't really know. But the turtles are not in the water all of the time. So there might be times of the year where you go survey a site and you don't find turtles, but turtles are present in the uplands, not in the aquatic site. So keep that piece in mind that I was saying earlier, uplands are really important to turtles. This paper really showed that the turtles, even when water is present, will leave the water, get up into the upland, and they don't hibernate. They just sit under leaf litter or under edges of logs or something, and they'll move around a little. Maybe they'll move a foot a day, but they're just kind of shifting around. So they're active, but not very active, but they're still up there. They're also a little bit vulnerable to predation. So there must be an important reason to leave the water, since water is often a refuge from predation. Zaragoza had a project in the Sierra Nevada where they watched pond turtles leave a pond that was drying, and it was a drought year, and they spent almost a year just sitting in the upland, just sitting there. So not eating, not reproducing, just sitting there. And if you drove by, say, I'll use myself as an example. Maybe on Zaragoza's site, I was hired as a consultant to come out and look for turtles, and I drive by and it's August and the pond is dry, and I say, well, there are no turtles, pond's dry. And maybe they delay their project, and I come back and it's March, when it should be wet, and I drive by and it's a drought year, but the pond's dry, and I think it's been dry almost a year. They can't be there, so they could just go out there and plow up the place and it'll be fine. In fact, the turtles were just in the upland, under leaf litter, under a little bit of duff. They all had telemetry units, so they knew exactly where they were. They do these micro movements, just like in the previous study. And there they were, 11 months of the year out of the pond. Now, they can't sustain that over their lifetime, but there can be years where you're going to go visit a site and don't find turtles, but they're present because they're just in the upland and you're not seeing them. And then my own work, I include here nesting, because keep in mind, for nests, they're in the upland for 11 months. So a nest can be in the upland from May to March, which leaves April. So 11 months of the year, and if you add in a little bit of time for movement for females nesting, we ended up with 340 days where you're going to have lots of active turtles in the uplands. So you have roughly a month of time, generally in April, where you can be, mowing or blading or disking or whatever, and you're not unlikely, but less likely to encounter a turtle in the upland. Now, if you average all these studies, 7 of them, the average is 7 months of the year a turtle can be out of the water, and that doesn't include nesting. Just the average adult just spending time in the upland for whatever reason. We don't know all these details. So keep that in mind. Upland use, nesting and non-nesting, can be extensive. So turtles do fine outside of the water. They drink a lot of water when they're in the water, especially when they're going to leave. And with that, then they carry all this moisture with them. Now, when you find a turtle coming back to water, it's often very light, so it's lost a lot of weight, it's very dehydrated, and they need access to that water. But if in the interim between it leaving the water and going into the upland and it returning, a development has occurred, it can't get to the water and it will definitely die. So we have to keep in mind that even when water is present, we might not find turtles in it, even when they're present in your in the site you're at. So again, moving around a lot is sort of typical for turtles looking for nesting sites. Keep in mind these little turtles are going to be in the upland. Takes them on average, from a study I know from Oregon, took about 2 weeks on average for a nestling, post-emergent turtle, a neonate. Neonate's the easiest word. For a neonate to leave the nest and make it to water, about 2 weeks. So they're making it maybe a meter a day or so, maybe a little more, maybe a little less, but also they're not going in a straight line. They're going zigzaggy because they don't know, any obstacle is an obstacle. So again, they're in the uplands all this time. The nests are in the uplands all this time. The uplands are where we do our development. So this is where turtles are most vulnerable. Now, in this case, we have nests in the upland. That's what the arrows are pointing to. If this were, I'm trying to remember the date, but I think this is something like February or March, because we're looking at the nests and I know where the nests are. Then the neonates might be coming out of the nests, so we'll have some nests in the ground, some neonates in the ground, and some adults moving from their overwintering upland sites back to the pond. So there are times where it's very vulnerable for turtles, and things like mowing can be a big problem. We had a turtle killed just, I think it was yesterday, at the state fair site that we work on for mowing. So they mowed at the wrong time. We told them when to mow. You mow in April and that's it. And they hit a turtle because they're out there in June when the females are out and trying to find nest sites. So I'm going to go through this with a kind of a schematic of the calendar again. And again, we use kind of the Julian calendar, which is January to December, from essentially day 1 to day 365. But I'm going to kind of follow the calendar. The turtles don't care what date it is, but I'm going to follow the calendar to just give you an idea of how this moves through. So nesting, again, will start about, and I say about because it can be earlier, it can be later, starts about mid-May, goes to about mid-July. The primary nesting season is definitely going to be in June through most of California. Now, if we start to go down that calendar timeline, the green now is showing you where the incubation of the nest is occurring. So if a nest is made in early May, it's incubating and it's going to finally hatch in, say, sometime in August, depending on when the nest was laid or the nest was made. And remember, it's subterranean hatching, so they're nesting underground and they're going to stay underground. And that's for most of California. Very southern California, they might come out at this time of year, but for most of California, it's going to be subterranean hatching. So then there's this period in this dark blue that I put up from the hatching time. So they're hatching underground in August, all the way through February. And remember, they're just laying underground, moving around a little bit, hoping a gopher doesn't come through, or hoping something doesn't dig them up. And then they're going to make their way to the aquatic feature at some point. And that's about this time. So the earliest I've seen is about the 3rd week in February. You'll start to see emergence. We see it all through March. Depends on when the nest was made. There'll be early nesters and late nesters. So there's early emergence and late emergence. And then, so this is a very vulnerable time for turtles because you're emerging from your nest. Your nest is also, if you remember, it's kind of eroded on the top. So stepping on it can crush turtles, as opposed to something like, you know, in the middle of summer, you could drive over a nest. It's fully solid and protected. But in this period, February and March, pretty vulnerable, can be crushed, can be flooded by a flood event, and then also predated. So very, pretty precarious time for these little neonates. So this is about the post-emergent hatchling time when they move to water. So maybe about late March to maybe mid-April, you're looking at a time where probably the peak in vulnerability for neonates is when they're moving from the nest site to the water site. And that's a time when it would seem like it's an ideal time for doing surveys, because maybe you could find, you know, if at our site where we're going to go on Sunday and Monday, there's going to be 60 nests or 70 nests every year. And maybe more because they'll double clutch. So some females single clutch, some double clutch. So maybe you have 100 nests out there, which might be 500 little neonates that all should be walking around March and early April. Seems like it'd be easy to find them, but you just rarely find them. And then here's this funny time where I really highlighted in an obnoxious color. So the neonates are generally not in the uplands between about the 2nd week of April through about the 2nd week of May. So there's this little block of time where I say, okay, that's time to mow, that's time to scrape the roads, that's time to spray, that's time to do whatever you're going to do, but do it in May. And if you're not doing it in May, you're probably going to be killing turtles. So that leaves us our entire development window in late April, early May. Now we know, I mean, you guys know, you're probably rolling your eyes at me right now. That's not realistic. I mean, there's going to be development and road repairs, and there's emergency projects and levee repair and all these kinds of projects we work on, and it occurs whenever they want to work on it. We had one just start last week on the Delta, and they're going to be doing stuff. But I said, okay, well, here's that piece where I'm going to give you the solution. In order to protect nests for turtles, you're going to have to survey for them in May or June every single day, 7 days a week, and mark all the nests you find and assume you're getting only about 20%. And that would be a good year, but it's probably not very effective, and it's really not biologically sound. So instead you go back a little and you build an exclusion fence in your work zone in April. If you're able to do that in April, you'll keep the turtles from nesting there. So if your fence is maintained, you build it in April, you maintain it for an entire year, then that means no adults are in there, no neonates are in there, and in your work zone, you're probably turtle free. That has to be a non-climbable fence, by the way, so no Urtec. Has to be like Animex fencing or wooden fencing or something similar. So that is the key. Now that doesn't work for most of our projects, and probably I would say, 85% of our projects are going to be just dropped on your lap. But this is how it really needs to be. We need to build an exclusion fence for our entire work zone, get the turtles out during the year you're maintaining the fence, and exclude them and keep them out for that year so you can go in there and tear up everything. The alternative is still viable, and that is you go out and do nesting surveys and you find nothing, but you have to trap or in some way determine the number of females you have. And whatever number that is, let's say it's 20 on some site. You have to multiply that by 1.6. That's the average number of clutches a female will lay in a year, 1.6. So I have my little calculator out. It's solar, so I have to hang it out the window here. 1.6 times 20. Okay, that equals 32. So that's how many nests you're going to have if you have 20 females on average. So we're just going to go through this exercise just for fun. So the average number of nestlings in a nest is 6.5. So you times 32 times 6.5 and you have 208. Okay, so that's how many neonates you would have on average. So these are all hypothetical, so the details don't matter. So let's say you were not able to put up your fence, but you have nests in the ground. You know you have about 20 females. Now you have about 208 neonates. You have to assume this is really going to be after the federal listing, because then you're going to have to actually count take. You would have to assume take of 208 minimum. So every neonate would be dead. And how do you mitigate for dead neonates? Well, the agencies don't allow you to. That's take that they might give you a take allotment of, say, 5, but it's not going to be 208. So how do we get around this? Well, the reality will be we put up the fence early and tell the project they have to be on hold. This is probably going to be the direction it goes. Now, listen, I run my own company, so I contact the clients directly. Some of you do too. I know they're not going to be happy. I shrug my shoulders and say, not my problem. They're the ones that are going to be making money on the development, or they're the ones that are obligated to fix the levee, or whatever it is. That's not my problem. My problem is to help the turtle. So that's where we're going to probably end up being. Either build your fence in April and exclude it and maintain it for a year, do your development inside, or calculate out what your take is. Now, even if you get one female, let's just say you get one female pond turtle, you're still looking at a take of 6. Most times you're not going to get a take of that many. So there's always going to be mitigation here. And the problem, I think, is As I've thought about this for many, many years, we as biologists have probably contributed to the decline of turtles as much as development. And by that, I mean to say we just didn't know. So we didn't know that if you don't find nests, that nests are still present and how many might be. So lots of populations of turtles don't have any recruitment at all. And that's probably because we aren't assisting them by assuming they're reproducing every year when they are. So I know there's some complexity in what I'm saying, but what I am saying is we have to learn to admit we're going to kill things. It's a sort of against the creed of consulting, which is always like, keep the project moving, keep the client happy. That's not the way my consulting firm works, but I understand that's how consulting firms work. But the issue will always be how many are we killing once the thing gets listed federally? And that will be your responsibility to determine. So that's why I say before this thing gets federally listed, get a scientific collecting permit, get turtle added to it, and start trapping turtles. So you know how you can calculate this number, not precisely, but generally, and you'll have some idea. But even one female present means you're going to have reproduction likely, and you're going to have take if you're not doing something like building your fence in early April. So that is the solution, which sucks. It's a terrible solution because I understand the reality of how projects work, but it is going to be, our option will be one of these two. Exclude them from the start, meaning put the project off for a year. Nobody wants to do that. Or calculate out how many you're going to kill and mitigate for that if you know how to mitigate for loss of a population. I don't know how. I'm working with the service on some of this stuff, but it's not going anywhere because we don't know how to do it. So go ahead.
Sorry, when it comes to maintaining the fence for a year long, like, would that be like going out to the site like once a week, or like how often would we be going out to? I mean, I know it's different, depends on site conditions and weather, but like just to try to account for it if we're making a proposal of this, like.
Yeah. I am so empathetic to that question because I do fencing. We have a year-round tiger salamander trapping project, and we're out there every single day. So I might bid to maintain it every day because it only takes a hole about that big for a turtle to get through. Turtles can dig, turtles can climb. So I would say, I would propose that every day, a few hours, somebody's going to have to go out there. Now, somebody else might propose, well, we're going to go out once a week. So their proposal will be 1/7 of mine. Somebody else still might say every couple of weeks we'll send somebody out there from Labor Ready. So their proposal might be 1/15 of mine. And, so I'm not going to get those projects, which is fine because they're problematic projects anyway. But somebody is also going to not do a very good job and we're going to lose turtles. So there's probably going to end up having to be a protocol where the agency decides you will maintain this, 4 days a week or 3 days a week or whatever it is. That's the only going to be the only fair way to do it. And then we get to blame the protocol instead of saying, well, company A is, unethical or lazy or whatever. And people say that, I'm sure, about me or everybody else's company. It doesn't matter. We just know the atmosphere of this stuff. But it's going to be a problem. There are lots of problems. And by that, I mean to say, I'm working with the agencies now with this kind of stuff as best I can. And they're shrugging their shoulders, and so am I. And we're just looking at each other like, what do we do here? And we're like, I don't know. Consulting, has a lot of really good brains in it. And maybe there are other people out there, if I say this enough, who will come up with an idea. And I was doing a talk to a group, and there was a guy in the audience who I have come to know and really like a lot, who is a geologist, not a biologist. He said, oh, what if we use ground penetrating radar to look for turtle nests? I was like, I don't know anything about that. That's a great idea, but I don't know anything about it. And on his own, he's been using that and testing it on quail eggs. He buries quail eggs and been using it, and it's kind of working. So we might get some use out of something like that, but I say some of the stuff to say to you guys, I don't have all the answers. Maybe you guys can come up with some stuff. When we're in the field, we can talk about it more, because the site you're going to go to, we did a major restoration project there on a site that had lots of turtles that we understood very well and knew where they nested, and still killed a bunch of turtles. So we'll talk about that in the field, but it has elevated my understanding of how difficult this is. And it isn't to dump it on you and say, oh, too bad for you. It is to say, though, we need to think creatively here, and we need to recognize and admit that we definitely are going to kill them. We definitely are. How many is what we're going to have to figure out. And what's the solution to killing a bunch of turtles? My solution has been to say to the agencies, 10 years of follow-up surveys for every project to see that if in a 10-year time you get any recruitment into your turtle population. And the agencies might then add on to that, and these are kind of discussions that are not formalized in any way, they're just casual ideas still. The agencies might say after that, okay, after 10 years, if you don't get recruitment, your project's still alive. You're still responsible for it after 10 years. After 10 years, if you get no recruitment, you have to bring in some females and males and do captive breeding to get recruitment. That will be the responsibility of somebody putting in a culvert. 15 years of post-project monitoring and artificial translocation. So it is not to say that that's what we're doing. It is to say we have to think about this in a way that aids in the recovery of the turtle. And this chart I'm showing you here is really just devastating information for us, because all these years that I've been a biologist, 38, we've not recognized this. We just go in there and start gouging up the place, including on my site, which I'll tell you about, because I'm not claiming to be like a know-it-all angel who never makes mistakes. We've killed turtles. And I'm sure I have a photo in here coming up. So this is really to turn this into a discussion more than a, look, it's doomsday. That's not what I'm saying. Don't tell all your clients, oh, it's never going to get better for you. You're going to be broke before you get your project in. It's really just to say, we have to talk about this. I see Katie asking a question.
Is there a possibility of catching females right before they make their nests and putting them in a protected fenced area so they make their nest there, or will they just stubbornly refuse to do it there if they don't feel like it?
It's a super good question, and there's complexities to all these answers. So when you pick up a female after you find her and you palpate her, you can put your fingers in and you can feel eggs in her. She will start to pee. So all that urine that she's collected in order to build a nest will be gone. So now you got to put her back in some water so she can build up that big bladder pod to be able to build a nest again. So you're going to have a site that has an aquatic feature where she can get more water again, but not be forced to stay in the water like a cattle trough or a swimming pool, like a kiddie pool, because she'll just drop her eggs in the water and then they'll be dead. So she'll have to have access to water and access to upland that is also protected from predators. So, is that something you could build on a site? On some sites, certainly. On other sites, probably not. So what do? Do we just bring her in and house her, artificially and make her lay her eggs and we re-release her? None of those questions have been answered, and I'm not saying that that's not a possibility. It's probably a likelihood in some of these scenarios. And the people who are maybe like you, who might be thinking about this, who decide, well, yeah, I do consulting, but on the side, I'm going to get a permit to collect a few turtles and see if we can get them to lay eggs in some substrate I create, and then incubate those eggs and see if we can get them to hatch. We know how to do that. And see if you can do that. I mean, you would end up, that consulting firm would be rich for a few years because they're the only ones who could do it. But it's going to have to be one of those kinds of things where we're all just tossing out these seemingly random ideas, but one will stick or two will stick or 50 will stick. And maybe we just try them all and hope for the best. But I like it. I want to hear all these ideas, because we got to come up with something, because what we're doing is not working. And then sorry, go ahead.
Sorry, I have a quick question. So I work on a lot of CEQA documents, And I'm just wondering if you're seeing measures like these, if anyone's writing these types of measures.
Zero, because for CEQA, it's still going to be a species of concern. It's going to be the federal government that's going to try to list it. And, you know, that's all NEPA. So CEQA, they don't really care right now. Nobody's even considering this. And I think the problem will be that this comes down just like a door slamming and everybody's like, what the hell? So that's why I'm trying to get the word out that we need to start devising something before the next round of listing includes the turtle. And it probably won't include the turtle as northwestern pond turtle. It'll include the turtle as southwestern pond turtle.
I guess I'm
Sorry,
just curious because when you're assessing impacts, you know, killing whatever that number was, 200 neonates potentially could be a significant impact under CEQA. So you'd have to mitigate for that.
I completely agree. I do, but people aren't aware that they're even doing that. So that is kind of the point of these talks that I'm giving, that the idea is that a person is told, go out and do turtle nest surveys, and we're going to put a fence around all the ones you find, and they find zero, so they assume there are no nests. And that assumption has been wrong over all these years. So what I'm trying to share with people is we have to make those assumptions more biologically sound, even when we can't find the nests. We have to assume they're present, assume they're in the area we're going to disturb, and mitigate it in advance of the loss. But the loss is still a significant thing, the actual loss. But this is one of those things. I've been doing this talk for about 4 years, and I can't find a company other than my own that does this. That even though they hear me say it, nobody wants to take that on. That's such a big thing. And so they're going to wait until they get pressured. And so I do a brown bag, because I'm in SAC, I do a little brown bag discussion for the state every now and then. And they're on my list for July. And I think once they start hearing it, it's going to be probably start coming down. But right now, nobody's putting pressure on anybody.
Thank you.
Those brief sounds tell me exactly what I feel. I'm a little dumbfounded by it because, you know, I've been doing this for 38 years. Not a single person really understands or seems to admit to the fact that we have probably, and I say this quite honestly, I think we've contributed more to the loss of turtles than the development itself, because we aren't admitting what is actually going on. It's been a tough thing to discover and to learn, and to try to share, because I'm not trying to point the finger at any individual company or person. I'm just saying we need to step up our game here, and if we're not going to learn how to fix this, we need to mitigate for it. The federal government is aware, and they're working at. The state is not, though. The state is just like, well, we're just going by what the documents say. Okay, that's fine. I don't work for the state. Thanks for your little chat statement. Like I said, I've been consulting for 38 years, and I get how consulting is, but I'm trying to be encouraging to say it's okay to say you don't know, but when you say you don't know, you have to do something about that too, and that's what we're trying to do. So I'll briefly go through kind of adult upland habitat use timing too. So my little green box says there's a little window when they're probably not in the uplands very much, not from my experience. And then I have this blue line down here, which is pond habitat type. So there's different behaviors in pond habitat type versus something like creek habitat type, and we'll go through that. So generally, if you kind of project upward, what I'm saying here is the nesting period is in May through July, so they're probably in the uplands. Some ponds dry in California very early on, and turtles, and project upward again. So say maybe as early as early July through October, the pond might be dry, and they're in the upland estivating. So you have turtles in the uplands as adults in addition to the nests. So as we move along, the pond might be, the dry period might be extended. So the turtles go from estivation, which is kind of a summer lack of activity pattern. It's not similar to hibernation really, even though it sounds the same. They're just not very active. Now they go into brumation, which is a winter period where they really are less active. And the pond might still be dry until early spring. We don't really know. But the turtles are in the upland during this period. And this would also count for some creeks, although I'll talk about creeks separately. This in around February is when the ponds start to hydrate again. Turtles will move back. They don't move immediately back, even though the pond might be wet in January. So it might be filling up and the turtles are still in the upland. They wait for a while because they don't want to go to a pond that's maybe 2 to 3 inches deep. They'll be in the water and be predated. So they wait for a while. The pond fills up even more and then they move to the pond. And about that time, they're going to go engage in the reproductive behaviors like mating and that sort of thing. So in a pond situation, you might have a period of time where the turtles are probably in the pond, exclusively in the pond, not doing much more in May and in April. And the rest of the year, they can be in the upland. So you have to be aware of that when you're doing, exclusion fencing, monitoring, post-project monitoring, all these kinds of things, because the adult turtles now might be in the upland from May to as late as January. So all through late spring, summer, fall, and part of winter. And then quickly, creeks and rivers are slightly different. They occasionally dry too, and the turtles will leave a drying creek or river. But in some cases, you might have something like the Mad River or Trinity River, where they're never going to dry, but they have pulse flows in the winter from big rain events, and the turtles will leave, not because it's dry, but because it's too wet and the flow is too vigorous and they can't tolerate that. So they'll just leave and be in the upland. So the general point is to say, we have either nests in the upland or big turtles in the upland quite frequently. And I don't think we think about that so much because we see them in the pond, but we're only seeing a percentage of the turtles. So just to give you an idea of that, we had a pond that had a population of about 65 turtles. And on any day that we went there, over a 20-year period that I monitored it, we would see a maximum of about 25 turtles. So, maybe a little over a third of them were in the pond at any one time. And the rest were in the upland. We don't know why. The individual turtle decides that. Some of them are probably in the water, underwater, but some of them are in the upland for sure. So we know that this is happening. And they also move pond to pond, creek pool to creek pool, creek stretch to creek stretch. So turtles move quite a bit. So again, just a couple of open windows where they're probably in the aquatic habitat pretty reliably, and that's a safe time to be doing things like mowing or blading or disking or those kinds of things around an aquatic feature. And so that's relating to this little piece of time. And outside of that, you just start increasingly running a risk. And so on our site that you guys will see, when they mow out there 4 times a year. We have the mower raised to 6 inches. So if they run over a turtle, they won't chop it up, even though they've done it in the past. Once they've raised it, they don't hit the turtles anymore. But we also put a biologist walking in front of the mower. Now that's not a fun job. I do it myself, but it's not a fun job, but sometimes you got to do it. Otherwise you're going to hit turtles. And when it's federally listed, it's going to be a bigger issue. So you have to be thinking this way sometimes. Here's a turtle nest that got hit by a vehicle that just didn't realize there was a turtle nest there. The vehicle ran over it at the wrong time of year. It just tore the ground up. Turns out the vehicle was an ATV, so they're tearing the ground up. Not meaning to be judgmental, but when you get on an ATV, there's a tendency to kick up dust and dirt. And this just dug up a nest and killed all the turtles in it. So there is this possibility that you can do this stuff even unintentionally. Here's a turtle up against the turtle exclusion fence. This is on the site I worked on. I think I'd shared with you over and over, we studied the site for 12 years, watched the turtles nest, figured that we understood where they were nesting, had a lot of confidence about it. We started our restoration project with a lot of exclusion fencing a year in advance, but turtles climb Urtec fencing, even when it's bent over in a funny way. They find a way to get over it or under it. They got on the wrong side, made a nest. We were blading, hit the nest, killed all the turtles in it. So even when you're on a site, not for a day or two looking for nests, but 12 years, following them every single day, 7 days a week during the nesting season, fencing and covering every nest and protecting it, and also kind of getting a big picture of how they nest and where they nest, this can still happen. And it happens to us. So I'm not saying us like, oh, look at us, we're great. I'm saying we were on this site being paid to protect every turtle, and we couldn't do it. The turtles are trying to do what turtles do. So I'm sorry, I'm just reading something in the chat. Christine asked, how do they eat in the upland? They don't eat when they're in the upland. Not the babies, not the adults. They have to be in water in order to eat. So they're fasting that entire time. Even if it's 300 days, they're fasting for 300 days. So keep that in mind about all this stuff. Turtles suffer a really tough life. And when you impact them greatly. So it's part of the kind of the notion that I'm trying to share here, that when they're in the upland, they're very vulnerable. They're not eating, they're not drinking, they're just sitting and hoping to get back to an aquatic feature that has food and water and protection and no barrier. And in our case, here's a barrier that we put up. We used Urtec fencing. I would not use it again. I would use Animex fencing or wooden fencing, which they can't climb. But any other fencing we used, any kind of mesh, we just see them climb right up. Even some hardware cloth that was 4 feet tall, we got a photo of a turtle kind of teetering on the top. They just try no matter what. So in the end, this is what you're hoping to find, hoping to get, hoping to protect, I'm sure. And this is what we're hoping to find too when we get out into the field. But it's going to take a little bit of thought and a little bit of effort. And I believe that as we progress through the next year or so, when the turtle's still a species of concern, that we can find some solutions, including, admitting that there's going to be loss on these sites. I think that has to be the first step, and mitigating for that. Because, when I suggest mitigation, I don't have to open up my wallet and pay for the mitigation. The client does. Now, most of my clients are agencies or organizations or nonprofits. So money is a different thing than maybe a development agent organization that, like back in my younger days when I did developments, I wouldn't worry so much about the developer. They're going to make several $100 million on some of the projects I worked on. So doing a little mitigation doesn't hurt them. Some of the agencies and nonprofits I work with, I still have to shrug and say, well, you got to mitigate, even if it's going to cost you a lot, even if your budget doesn't have mitigation money in it, we still got to do it. So we just have to come up with some solutions. And I think working together on some of this might help. And as we're in the field, I'm really hoping for a good discussion about this, because I think what you guys help me to understand, I will be sharing as well. Some of the resources I've used, I just want to kind of share with you. I have I think I said this earlier, all of the papers published on pond turtle in a bibliography defined by category. So status and range and reproduction and behavior and feeding and all that stuff. I'll send you that general list of all the publications. And if you need one of those, I'll definitely send those to you. Just request it from me. These are the ones I kind of regularly use, including some of my own, to deal with turtle nesting, turtle nests, and upland habitat use. And most of these are quite good and worth having. If you need any of these, just let me know. Like I say, I can get most of these, if not all of these, to you. So I want to spend just a couple of minutes on our field meeting, then give you guys some time for questions, and we're going to break off here and be done. So just as we move through, just remember I can't switch your days. I have limitations on how many people I can take out. We're going to be meeting in Martinez. I think I sent that information out to you. If you didn't get it, or you lost it, or you deleted it, let me know. The site is going to be sewage detention basin ponds, but they're not primary or secondary, so it's clean water. They don't want you to drink it or get in it, but it's really pretty clean water. There are 6 ponds out there that we'll walk around There's a levee system we'll use. It's very, very easy access. There are flush toilets, sinks to wash your hands, a place for us to eat. We're going to be looking at the project that I worked on, including telemetry, including all this nesting. We did nesting predation studies. So what's not clear is there's a fence along those little red and white dots. And wherever a turtle made a nest, the white dots are predated, the red dots are nests we protected. So when you have a fence on a site, and I'll talk about this in the field, and this project we did, the predators figure that out very, very quickly. So any fence you put in is a new impact, and they just focused on those nests so quickly. But we'll focus on that in the field more. We'll probably see a little bit of this. So in predated nests, I'll go out there on Saturday before our Sunday, and I'm going to set some turtle traps. So hopefully we'll be able to look at some live turtles as well. And in general, we'll just be out in the habitat. And I think I gave you a list of stuff for those days. Again, I'll send that kind of bibliography version. I have it sort of annotated. I'll send that out to you guys, and you can feel free to ask questions before the meeting. Until then, I'll meet you guys in the field, but I'll hang around for at least another 10 minutes answering questions if you have any. But that's going to be about it for our workshop lecture, and I'll stop the recording too. I'll probably just let it go in case you guys have questions, but as soon as I stop sharing, I'll stop the recording, and when your questions are over, we'll just be done with this today. But thank you guys for the questions you had. Every single one of them was appropriate and great, and I'm hoping to get more when we're in the field.
Thank you, Jeff. That was an awesome lecture. Excited about the workshop, the field trip. I had a question about IDing eggs and neonates. Are the resources that you provided already, the 2 books, do those include eggs and young, or is there something else we could look at?
Yeah, eggs are super tough. There is not a good resource. It really is about experience. If you send me photos of eggs, I'm going to need to have a ruler in there. So I'll bring some eggs with me, and you guys will see some pond turtle eggs. The problem is the other, 12 non-native species have similar eggs. So you might be able to identify pond turtle egg from gopher snake egg, and bird eggs for sure. But from another turtle, I can guess because I know like red-eared slider make more rounded eggs, like their eggs are more sort of rounded, and pond turtle eggs are more squatty, and the length is different and the number is different. But if I'm looking at a bunch of the cooters or some map turtle or something, I don't know. If I found eggs and they were viable, I'd try to hatch them and see what they were, but the eggs are super tough. Neonates, I got to tell you, I do lots of workshops with my friend Dave Cook. And just 2 weeks ago, he sent me a photo of a neonate, said, "What is this turtle?" And Dave knows turtles well. The neonates are tough. If you catch one, take photos of the top, bottom, and the front of the face and send me a photo, and I will give you my best guess. I think they're very tough, but I can send you some photos, but I would say the best thing to do is type in turtle hatchling of whatever species, like Western pond turtle hatchling or pond turtle hatchling, into Google, and then hit images, and you'll get some ideas to kind of compare to whatever you might have. But red-eared sliders definitely have like a serrated carapace right by the tail on adults and the young, so that's helpful. But most of the other ones, they're tough. And I'm afraid nobody's written anything, nobody's done anything. That's wide open, and if somebody wants to work on that, I'll help as much as I can. That's a good one.
Sounds like fun. Thanks.
Yeah. If there are no other questions, we'll be happy to end this. So it's a little after our time anyway, and I'm happy to answer any questions in the field through text, through email, but I will meet everybody in the field. So I think, like I said, if you did not get the information I sent, which should have directions and what you should bring, send me a quick email and I'll forward that over. And in the meantime, I'll forward over that list of literature. And if there's anything on it you want, just let me know. And outside of that, feel free to ask questions anytime, but I'll see you guys in the field.
Awesome. Thanks, Jeff.
Thank you, guys.
Thank you.
Thank you.
Thank you.
Thank you.
Thanks.